In this video, we are going to discuss about OOPS concepts in Python programming. Generally, programming languages are mainly classified into two types. The first one is procedure-oriented programming languages. So the first one is procedure-oriented programming languages. Second one is object-oriented programming languages. So procedure means a function. So we know what is a function. Function means a collection of statements which are useful in order to perform a task. Python is best example for both procedure-oriented as well as object-oriented programming languages. In this video, we are going to discuss about OOPS concepts that are supported by Python. So mainly we have 6 concepts are there. The first OOP concept is class. The second one is object. Third one is encapsulation. Fourth one is abstraction. Fifth one is inheritance. And the last one is polymorphism. So these are the major features of OOPS, major concepts of OOPS. Now let us discuss all these concepts one by one. So the first concept is class. What is a class? Class means it is a blueprint. Class is a blueprint. It is a blueprint or plan, or we can also call it as plan, from which an object is created. So this is the most commonly used definition for the class. So what is a class? Class is a blueprint or plan from which an object is created. If we take the example of construction of a house, so first we need a blueprint. So first we need some blueprint, okay, where bedroom is, where kitchen is, where dining table is. So we need some blueprint. That is nothing but plan. According to the blueprint or plan, we are going to construct the house. This blueprint or plan is called as class, whereas this constructed house is called as object. It is a blueprint or plan. Class is a blueprint or plan. According to the blueprint or plan, we are going to construct the house. So this is the most commonly used definition for the class. Okay. So that means here we can call class as a logical entity. So that means it has no physical existence. If you take the example of manufacturing a mobile. So in order to manufacture mobile, we need some RAM, ROM, some speed, some camera. So according to that, we will design the plan. So we need RAM, ROM, next to some camera. So first we will design the class. Okay, we need all these requirements. Okay, so this requirement, this is called as blueprint. Next, once blueprint is over, according to the blueprint, we will manufacture the mobile by taking all the components and by assembling all the components. We are going to manufacture the mobile. Okay, so once blueprint is over, then we can construct as many number of houses as we want. So that's why we can call class as it is a collection of objects. Class is a collection of objects. Once the class is created, once the class is declared, then we can create as many objects as we want. Once the plan is created, once the blueprint is created, we can build as many houses as we want according to the plan or blueprint. So we can say that class is a collection of objects. Okay. And one more important point is class is a collection of variables and functions. So class mainly contains variables and functions. The variables and functions which are declared inside a class are called as members of the class. So what are members of the class? Members of the class are nothing but the variables and the functions which are declared inside a class are known as members. Okay. Now let us see how to declare a class in Python. Practically we will discuss in the next video. The syntax for declaring a class is like this. We have to use a keyword called class, and it should be followed by class name. For class name, simply we have to follow the rules of identifier, and it ends with colon. In C or C++ or Java, it ends with curly braces. Okay. After the class name, or in C we use a structure name. After the structure name, we have to use the curly braces. Curly braces specifies the starting of the block, whereas Python means it is indentation language. So we have to use colon. Colon specifies start of the block. And after that, we can place as many statements as we want. Mainly we places variables and functions. Variables and functions. Okay. Variables and functions. Let us take the example. Let us take one example. Let the name of the class is student. So class student. Next it ends with colon. Here we can declare, here in Python there is no need of declaring any variable. Directly we can perform the initialization. Let the first variable is roll number. Roll number is equal to 10. Next variable is name. Name is equal to some Ramu. Now what will happen? Roll number, it is assigned a value called 10. Now roll number will becomes integer data type. So next we assign some name. Now next what will happen? Name means roll number. So class, what is the name of the class? Roll number. Name of the class is student. Next we can declare as many variables as we want. So for space constraints I am writing here. Next we can declare some functions. So def. In Python a function is defined using the keyword def. So def space. We can use any function name. Let the name of the function is right, colon. Within this we can place some body. So likewise we can declare the class, and we can declare the class. So practically in the next video we'll see. So this is about what is a class. Okay. In the next video we will discuss practically how to create and how to create the class, and how to create the object, as well as how we can access the members of the class. We will see practically in the next video. In this video, we will mainly focus on what are these concepts. Okay, what is what? Okay. The next feature is object. So, what is object? The most commonly used definition for the object is it is an instance of the class. Object is an instance of the class. An instance of the class. Okay. So, once the blueprint is created, then we can build the house based upon the blueprint. Okay. So it is object means it is complete replication of our blueprint. That replication is nothing but instance. Okay. And one more important definition is object is any real world entity. Object is any real world entity. So anything that we see in the world is nothing but an object. Here this marker pen is an object. This duster is an object. AC is an object. Fan is an object. So anything is an object. Okay. In Python, everything is object. Data types will also be treated as objects in Python. Int is object. Float is object. Everything is object. Okay. Here object is called as physical entity. That means object has physical existence. Object is a physical entity. That means the entity which has physical existence. Whereas class is logical entity. Class is a logical entity. That means class doesn't have any physical existence. Class means some plan. Okay. So that is about what is object. Now let's see how to create an object. Syntax for creating an object. So very simple. The syntax for creating an object is like this. Object name is equal to class name. Object name is equal to class name. Next we have to use left parenthesis, right parenthesis. Okay. Let object name is S1. S1 is equal to class name. Previously the class name is student. So S1 is equal to student. Okay. So an object is created. That object name is what? S1. So likewise we can create n number of objects. So what is the use of object? Object is mainly useful in order to access the members of the class. So class contains variables and methods, variables and functions. Functions can also be called as methods. So in order to access them, we use the object. So how we can access them? Simply we use dot operator. S1 dot roll number. Let the roll number is 10. Next S1 dot, let we want to call the function write. S1 dot write. S1 dot write. So likewise we can call the objects. So this is about object. Now let us see about the next feature of OOP, that is encapsulation. Encapsulation. What is encapsulation? First let us see the definition. Encapsulation means so third feature of OOP is encapsulation. So what is encapsulation? Encapsulation means combining variables and functions under a single unit called class. Under a single unit called class. So generally class contains what? Variables and functions. If you place variables and functions inside a class, then it is called as encapsulation. So that combining can also be called as binding. So binding means placing. So if you place variables and functions in a class, then it is called as encapsulation. Now let us see the next feature, that is next concept, that is abstraction. So what is abstraction? Abstraction means showing essential features and hiding implementation details. Hiding implementation details. So this is abstraction. So what is abstraction? Showing essential features. That means representing essential features and hiding the implementation details. If you take the example of bike, we can drive the bike, but we don't know how clutch is internally implemented. We don't know how internally gears are implemented. We don't know internally how brakes are implemented. Okay, we don't know those implementation details, but we can drive the bike. Okay, let us take the example of a website or mobile app. We can work with any website or mobile app, but we don't know how it is internally implemented. We don't know which programming language they used. We don't know which scripting they used, which scripting language they used. We don't know which server-side technology they used. But we can work with, but we can use that website or mobile app. That is nothing but abstraction. Abstraction means only showing essential features to the user and hiding the background or implementation details. So Python also provides what? Abstraction. Now let us see about the next feature, that is inheritance. What is inheritance? So let us erase this portion. Let us see about inheritance. Inheritance means, let us see the next property, next concept of OOP, inheritance. Inheritance means creating a new class from old class. Creating a new class from old class. Creating a new class from old class is called as inheritance. So what is the major use of inheritance? Means reusability is the major use of inheritance. Let we have a old class. This is the old class. If we create the new class from the old class, then it is called as inheritance. So what is the use of inheritance? Reusability. Reusability means we can use the members of old class in the new class. So without declaring the members of old class, we can use all the members of the old class in new class. So that is nothing but inheritance. So reusability. Reusability means using the members of old class in new class. So what is the major advantage? Means reusability. The best example for inheritance is human being. If you take any human being inherits the features or genetics from his parents or from his grandparents. We inherited our all body features, nose, eyes, ear. Okay, we inherited all the features from our grandparents and parents. That is nothing but inheritance. We have different types of inheritance are there. Single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. We will discuss all those concepts in the upcoming videos. Okay. Let us see the last concept, that is polymorphism. Polymorphism is derived from two Greek words. The first word is poly, the second word is morphism. Two Greek words. They are poly and morphism. So poly means many, morphism means forms. Representing one thing in many forms is called as polymorphism. Okay. Mainly we have two types of polymorphisms are there. The first one is compile time polymorphism. The second one is runtime polymorphism. Okay. Compile time polymorphism means which method will be called. That will be decided during the compilation time. Runtime means which function will be called. Method and function both are same only. Which function will be called, that will be decided during the runtime or execution time. The best example for the compile time polymorphism is function overloading. Whereas the best example for the runtime polymorphism is function overriding. So we will discuss about what is function overloading and what is function overriding in the upcoming videos. In this video, we are going to discuss about class and object in Python programming, both theoretically as well as practically. First, let us see about what is a class. What is a class? It is a blueprint or plan. It is a blueprint or plan from which an object is created. So what is a class? Class means a blueprint or plan from which an object is created. If you take the example of construction of a house, first we have to design the plan or blueprint. How many rooms are there? How many bedrooms are there? How many halls are there? And what is the dimension of each and every room? First we have to design the blueprint. According to the blueprint or plan, we will build the house. This blueprint or plan is called as class, whereas the constructed house is called as object. So this is the definition for a class. Class is a blueprint or plan from which an object is created. Now let us see the next point. Class is a collection of objects. Class is a collection of objects. Once we have created the class, then we can create as many objects as we want. Once we design the blueprint or plan, then we can construct as many houses as we want according to the blueprint. So according to the blueprint, we will construct 100 houses, 20 houses. So we can say that class is a collection of objects. Now let us see the next point. Class is a collection of variables and functions. So in a class, mainly we can have two things. First one is variables and the second one is functions. Functions can also be called as methods. Let us see the syntax for declaring a class. Let us see the syntax. In Python, we declare a class using the keyword class, and class is followed by class name and it ends with colon symbol. Colon specifies start of the class. In C, C++, Java, C#, we use curly braces. Curly braces specifies start of the block, whereas in Python we use colon. Colon specifies start of the block, start of the class. So class contains several statements. It contains several variables and several functions. Okay. So this is the definition for declaring a class. Now let's see an example. Let us declare a class. Let name of the class is student. Here I am using S as uppercase letter. In student, S is uppercase letter. It is our choice. If we want, we can declare lowercase letter also. It is our choice. In Python, there is no need of any data type in order to declare a value, in order to declare a variable. In C or C++ or Java, in order to declare a variable, we must need data type. But here there is no need of any data type. Let the student class contains two variables. Let the first variable is roll number. Let the roll number value is 10. And the second variable is name. Let name is some Ramesh. Name is some Ramesh. Okay. Here 10 is assigned to the roll number. So now roll number will become integer data type. Here Ramesh is assigned to name. Now Ramesh becomes, now name becomes what? String. We know what is a string. A collection of characters which are enclosed in either single quotation or double quotations. Here we use a single quotation. So now name becomes the string. Now some variables are specified. Now let us define the function. Let us define the function. DEF. A function is defined using the keyword DEF. Let name of the function is display. So DEF display. In function we must pass self as the argument. Any function in a class must contain self as the argument. Self as the argument. So what is self? Self always points to the current class. Self always points to the current class. By using self, we can access the variables of the class. By using self, we can access the variables of the class. The variables which are declared inside a class but outside all the methods, they are called as instance variables. Here roll number and name are called as instance variables. Why? Because this roll number and name is specified within the class and on top of all the functions, or on top of or outside all the functions. So what is instance variable? The variables which are declared inside a class but outside all the functions. Okay. If we want to access instance variables from a function, we must use this self. We must use this self. Okay. So let us display roll number and name. So print roll number is comma. So roll number value is available in RNO. Next to print. Let us display name. Name is comma. Name is available in a variable called name. We must use self. So self dot RNO. Next we must use self here. Self dot name. Okay. Self dot RNO. Self dot name. We must use self in order to access the instance variables. Okay. So display function is over. Next, class is over. Here these variables and this function is called as members. The variables and functions which are declared inside a class are called as members of the class. So roll number, name, this display function is nothing but members of the class. Okay. Now let us see about object. What is object? What is object? The most popular definition for the object is, it is an instance of the class. Object is an instance of the class. So our house, so once a class is declared, once a blueprint is designed, then our house is called as object. So that object is nothing but exact replication to class. So we can call object as an instance of class. Okay. And object is any real world entity. Object is any real world entity. Anything that we will see in the world is nothing but object. This marker pen is an object. This duster is an object. Fan is an object. AC is an object. This board is an object. Everything is an object. Okay. Next, what is the major difference between object and class? Object is physical entity. Physical entity means the entity that has physical existence, whereas class is logical entity. Class means that it doesn't have any existence. Class means a blueprint. Okay. So class is a logical entity, whereas object is a physical entity, the entity that has some existence. Earphones, it has some existence, so it is an object. Okay. Next, let us see how to create the object. The syntax for creating the object in Python is very simple. Object name is equal to class name, and after class name we have to use left parenthesis, right parenthesis. Object name is equal to class name. So why we are creating the object? Object is mainly useful in order to access the members of the class. Here this class contains two instance variables and one function. We can access that function as well as those two variables with the help of the object. So how we can perform, how we can access those members? We can use dot operator, we can use period operator, object name dot roll number, object name dot name, object name dot function. Okay, likewise we can access the object. Okay, now let us continue with this program. Now let us create an object. Here all these statements are nothing but all these statements are body of the class, but we have to create an object from outside the class. So after that we have to click on the enter button. Next we need to click on backspace, so the cursor will be here. Again we need to click on backspace, so the cursor will be here. So from the first character onwards we need to create the object. So let the object name is S1. Here what is the class name? Student. Student is the class name. Here we have specified S as uppercase letter. S1 is equal to student. So here S1 is the object. Now by using S1 we can access these variables as well as this function. Already here roll number value is 10, name value is 10. Okay. Now let us use S1 for calling the display function. So S1 dot display, S1 dot display, S1 dot display. Now what will happen is whenever display function is called, then control goes to the display function. Here what is the output? Roll number is comma self dot roll number. So whenever the self is used, then it access the instance variable of the class. So self dot roll number means this variable will be accessed. So roll number is 10 will be printed. So what will happen? Roll number is 10 will be printed. Next, name is here, this is not needed. Name is self dot name. So self means this instance variable will be accessed. So name is Ramesh will be printed. Name is Ramesh will be printed. Now let us create one more object. Okay. So how to create the object? S2 is equal to student. Student. Now with the help of this S2, access the instance variables also. S2 dot roll number is equal to 20. Next S2 dot name is equal to, let the name is Mahesh. Let the name is Mahesh. Next call the display function S2 dot display. S2 dot display. So S2 is equal to student. An object is created. Here the members of S1 are what? 10 and Ramesh. Okay. Now here we change the values. S2 dot roll number is equal to 20. Now in S2 what will happen? In roll number 20 will be stored. Next S2 dot name is equal to Mahesh. Now in S2 object name means Mahesh. Next S2 dot display function. So control goes to the display function. Now in S2 object what is roll number? 20 is the roll number and Mahesh is the name. So roll number is 20 and name is Mahesh. So that will be printed. Okay. So in this way we can here while calling the display function there is no need to pass any parameter. There is no need to pass any parameter. If the display function has some parameters, if the display function contains some name and some roll number, then we need to pass those parameters. But that we will discuss in the constructor concept. We have parameterized constructor. So parameterized constructor means here through the constructor we have to pass some values. So in that concept we will discuss about how to pass values to the corresponding constructor and how to pass values to the user defined functions. But here we are not passing any values here. Here if we want we can specify, we can provide some value here also. In the function also we can provide the value. For space constraints I am writing here. In display function let we have a statement like this. Roll number is equal to 100. roll number is equal to 100. Next to print roll number. Print roll number. Here this roll number is declared inside display function. So this is called as local variable. What is local variable? Local variable means the variables which are declared inside a function. This roll number is declared inside this display function. So this roll number is called as local variable. Here we didn't use as self. If we didn't use as self, then what will happen is this local variable will be accessed. Now roll number means 100 will be printed. This 10 won't get printed. Why? Because here we didn't use as self. If we use as self, then only instance variables will be accessed. Whereas if we don't use as self, then local variable will be accessed. So this is about class and object in Python. Now let's see practically this program. Now let us see the program execution. Here I am opening IDLE. So file, open a new file. Now let us type the program. Class. Let name of the class is student. student. In student, S is uppercase letter. It is our choice. We can give lowercase letter also. There is no problem. Roll number is equal to 10. Name is equal to Ramesh. Here these two variables are called as instance variables. The variables which are declared inside a class but outside all the functions. And we are defining display function, def display. We know that in class we must pass selfie as the argument. So here the function must accept one parameter. So here display roll number and name. So print, let us display information. Roll number is. Here in order to access the instance variable, we must use self dot roll number. Next to print, self always points to the current class. Next we are displaying name. Name is comma display name. We must use self. So self dot name. Okay. Next, class is over. Next we have to create the object. In order to create the object, we have to come out from the class scope. So for that, let us type backspace key and type backspace key one more time. Okay. Now let us create the object. S1 is equal to, what is the class name? Student, left parenthesis, right parenthesis. Okay. Now let us call the display function S1 dot display. Here display function, while calling the display function, there is no need to pass any parameter. Okay. Now let us save the program. Alt F, save as. Let us save the program. Let name of the program is class and object. By default, py will be taken as the extension. Let us run the program. For running the program, we have to press F5 key. Run module F5. Roll number is 10. Name is Mahesh. So information is displayed. Now let us create one more object. S2 is equal to student. So an object is created with the name S2. Now with the help of S2 object, access the instance variables. S2 dot roll number is equal to 20. S2 dot name is equal to, let the name is Mahesh. So now in the second object, roll number is 20, name is Mahesh. Now display those information. So S2 dot display. Now let us save the program. Control S. Now let us run the program. F5. So first object information is roll number is 10, name is Ramesh. Second object information, roll number is 20, name is Mahesh. Next, if we want, we can provide the value for the variable inside the function also. Let roll number is 100. So this variable is called as local variable. Why? Because this variable was declared inside a class. Local variable. Now let us display roll number, RNO. Now which variable will be displayed? Here we didn't use a self. If we use a self, then what will happen is instance variable will be printed. But here we didn't use a self. So local variable value will be printed. Control S. Let us check once. So first local variable value got printed. Next to first object information. Next to local variable value got printed. Next to second object information. Okay. This is about class and object. In this video, we are going to discuss about constructors in Python, such as what is a constructor and different types of constructors. First, let us see what is a constructor. Constructor is a special method. Constructor is a special method which is used to initialize an object. Which is used to initialize an object. So constructor is nothing but a method only which is useful in order to initialize an object. Generally, object contains instance variables or attributes, as well as methods also. Generally, object contains instance variables or attributes. What are instance variables? The variables which are declared inside a class but outside all the methods. Generally, instance variables are declared on top of all the methods. After the class and on top of all the methods, we declare the variables. Those variables are called as instance variables or attributes. Constructor is mainly useful in order to provide initial values to initial instance variables or attributes. So why it is called as constructor? Why? Because constructor constructs the object. Constructor constructs an object. That's why it is called as constructor. Here, constructing an object means generally object contains instance variables or attributes, and constructor provides values to the instance variables or attributes of the object. So that's why we are calling it as constructor. Constructor is constructing an object. It is providing values to the instance variables or attributes of the object. Now let us see the syntax for defining a constructor. In order to define the constructor, we have to follow this syntax. We have to use a keyword called def. Def stands for definition. Why? Because constructor means a special method only. So we know that we define the method using def keyword. Constructor means after the def keyword, we have to use space. After space, double underscores. Here name of the method is init. Init stands for initialization, in order to initialize the object. And after the init, we have to use double underscore. Within the parenthesis, we have to pass self as the parameter. Why? Because we know that in a class, if we define a method, then we must pass self as the parameter. Self always points to the current class. We can access the instance variables or attributes or the methods by using the self keyword. And this colon specifies start of the constructor, next body of the constructor. We can define n number of statements as we want. Okay. In this way, we can define the constructor. Now let us see how to call the constructor. There is no need to call the constructor explicitly. At the time of object creation, implicitly that constructor will be called. So when the constructor will be called? At the time of object creation. At the time of object creation. Whenever an object is created, then automatically that constructor will be called implicitly. There is no need to call the constructor explicitly. So this is about what is a constructor. Now let us see about an example program for demonstrating the constructor, and then we will see different types of constructor. Let us see an example. So for that, let us declare the class. So class, let name of the class is student. In student, let S is uppercase letter. If we want, we can give lowercase letter also. There is no problem. Next, let us define the constructor. In order to define the constructor, we have to use def keyword. Next, space, double underscore. Name of the method is init. Next, double underscore. And we need to pass self as the parameter. And colon specifies start of the constructor. Okay. Double underscore init. And after init also, we have to use double underscore within the parenthesis self. Okay. Next, print of. Let us display some body. let the body here is inside constructor. Inside constructor. So this is the body of the constructor. Next, come out from the class and create an object. Okay. So we have to press enter key. Next, we need to press backspace key. Whenever we press backspace key, then the control will be at this position, at D cell, at after in this column only we will have that cursor. Next, again we need to press backspace key, so the cursor will be here. So we need to create the object now. Let name of the object is S1. So S1 is equal to student. So we have to come out from the class scope. Okay. After that only we need to create the object. So at the time of object creation, automatically that constructor will be invoked. So whenever an object is created, then the constructor will be invoked and the body of the constructor will be executed. So here what is the body? Inside constructor. That message will be printed. That message will be printed inside constructor. Let us create the object one more time. S2 is equal to student. Then what will happen? So second time an object is created. So second time this constructor will be called. So this message will be printed one more time. So inside constructor this message will be printed twice. Why? Because two objects are created. Now let us see about types of constructors. Mainly we have two types of constructors are there. The first one is parameterless constructor. Parameterless constructor. The second one is parameterized constructor. Constructors are mainly classified into two types: parameterless constructor, parameterized constructor. First, let us see about what is parameterless constructor. The name itself specifies the meaning. If the constructor is defined without any parameters, then it is called as parameterless constructor. So parameterless constructor means the constructor with no parameters is called as parameterless constructor. If you take this example, this is an example for parameterless constructor only. In any method, in any constructor, we must pass self as the parameter. We should not treat self as the parameter. Okay. So this constructor is not accepting, this constructor doesn't contain any parameter. So we can say that this is an example for parameterless constructor. Now let us see the second one. The second one is parameterized constructor. The name itself specifies the meaning. Parameterized constructor means the constructor with parameters. If a constructor is defined with parameters, then it is called as the parameterized constructor. Now let us declare some parameters inside the constructor. So in addition to the self, let us declare some parameters. Let the first parameter is rule number, next parameter is name. In any constructor, the first parameter is self only, or in any method, the first parameter is self only. Okay. Next colon. Next, in order to access this rule number and name, we have to use the self. So self dot roll number is equal to roll number. Next, self dot name is equal to name. If we want to access any instance variable, then we must use self. Okay. Self dot roll number is equal to roll number. Self dot name is equal to name. This is nothing but a constructor. Now let us define a method in order to display roll number and name. So void display. So this is a method. So it should accept self as the parameter. In this method, display roll number and name. So print roll number is here. What is the parameter? Self. We must use self argument. Self dot display roll number RNO. Likewise display name. So print within the quotations name is, we must use self argument. So self dot name. So class is over. Next, to come out from the class scope and create an object. So S1 is equal to student of, here this constructor accepts how many parameters? This roll number and name, two parameters. So we have to pass two parameters now. First parameter is roll number and the second parameter is name. Let us pass roll number. Let the roll number is 10. Let the name is Ramesh. Here an object is created. So at the time of object creation, automatically that constructor will be called. Here what is the roll number? 10. So 10 will be passed to RNO. Next, what is the name? Ramesh. Ramesh will be passed to name. Ramesh will be passed to name. Here what is the name of the object? S1 is the name of the object. So here we have two parameters are there. Here this roll number, this name is nothing but instance variables or attributes of the class. This roll number and name is nothing but instance variables or attributes of the class. There is no need to declare roll number and name here. Here what is the name of the object? S1 is the name of the object. And what is the roll number? 10. What is the name? Ramesh. So in S1 object, now roll number is 10. Name is Mahesh. So this roll number and name are nothing but instance variables of this class. There is no need to declare roll number and Ramesh. Okay. Next, let us call display method s1.display. S1.display. There is no need to pass any parameter here because here display method doesn't have any parameter. Okay. So whenever we call display method, then the control goes to the display method. So in S1 object, what is roll number? Roll number is 10. Name is Mahesh. So that information will be printed. Okay. Next, likewise we can create n number of object. Let us create one more object. S2 is equal to student. Let us call display method. Let us call display method. So S2 is equal to student. And how many parameters we have to pass? Two parameters. 20 comma Mahesh. Mahesh. So here an object is created. At the time of object creation, automatically that constructor will be called. Here the roll number is 20. So 20 will be passed to roll number and Mahesh will be passed to name. What is the name of the object? S2. S2 is the name of the object. So what is roll number? Self.roll number is equal to roll number. What is the roll number? We passed 20. So 20 will be stored in roll number. And what is the name here? Mahesh. So Mahesh will be stored in roll number. So S2 object information is roll number is 20, name is Mahesh. S1 object information is roll number is 10, name is Ramesh. Next, S2.display method. So control goes to the display method and roll number is, what is the roll number in S2? So 20 will be printed and what is the name in S2? Mahesh. So Mahesh will be printed. If you want, we can provide the values from here also. Okay. Let us call the constructor here also. S3 is equal to student of 30 comma Mahesh. 30 comma Krishna. Let the content is Krishna. So here third object is created. So one more time constructor will be called. So now the roll number is 30, name is Krishna. S3 object information is roll number is 30, name is Krishna. Next, instead of calling the display method, we can print here also. It is our choice. So print of roll number is, here we must use what is the object name. S3 is the object name. So we have to use S3. S3 dot roll number, comma. Next to name is, within the quotation name is, comma. S3 dot name. Likewise we can access. Okay. So this is about constructors and types of constructors in Python. Now let us see the program execution practically. Now let us see the program execution. Let us open IDLE and open and create a new file. So go to new file, new file. Let us create a class. Let name of the class is student. In student, S is uppercase letter. That is your choice. You can give lowercase letter also. There is no problem. Let us define the constructor def space double underscores. Next, name of the method is init double underscores. Next, we must pass selfie as the parameter. If it is a method or constructor, we must pass selfie as the parameter. Next, let us display some body. So print inside constructor. Inside constructor. So constructor is over. So let us come out from the class scope. So press backspace key and press backspace key one more time. Now let us create the object. S1 is equal to student. S is uppercase letter. Now let us save the program. So save as. Let name of the program is constructor. Constructed by default, py will be taken as the extension. Py stands for Python. Now let us run the program. So press F5. So inside constructor. So whenever an object is created, then automatically constructor will be called and that message will be printed. Now let us call the constructor one more time. Let us create the object one more time. S2 is equal to student. So 2 times an object is created. So 2 times constructor will be created. So inside constructor, that message will be printed 2 times. This is nothing but default constructor. What is, default constructor, or we can call it as parameter less constructor also. So parameter less constructor means the constructor without parameters. So this is an example for parameter less constructor. Now let us define parameterized constructor. Parameterized constructor means constructor contains some parameters. Let roll number and name are the parameters. Now define the body. Define the body. Self dot roll number is equal to roll number. So self means it is an instance variable. Okay. Next to self dot name is equal to name. Now let us create an object with two parameters. So 10 comma, let us pass Ramesh, two parameters. Now in addition to defining the constructor, let us define a method. So def display, in order to display the content. Def display, we must pass self as the argument in a method or in a constructor. So let us display the information. So print roll number is comma roll number. Next to print, let us display name. Here it is a method. If we want to access instance variable of a method, then we must use self dot roll number. Next, let us display name. So print name is self. We must use self. Why? Because here roll number and name are nothing but instance variables. Name. Okay. Next here, let us display some body. Print S1 object info. Information. S1 dot, let us call display method. S1 dot display. So let us see what is the output, and then let us create one more object after watching the output. Control S, F5. So S1 object information. What is the S1 object information? Roll number is 10, name is Ramesh. Okay. So whenever an object is created, then automatically constructor will be created and constructor will be called. So 10 will be passed to the roll number and Ramesh will be passed to the name. In S1 object, now roll number will become 10, name will become Ramesh, and then we displayed the information. Likewise, let us create one more object. S2 is equal to student of 20 comma Mahesh. Now let us display some information. Print S2 object information. That means we are printing information of the second object, S2 object information. Let us call the display method, S2.display. Now let us save the program and see the output. So S1 object information is roll number is 10, name is Ramesh. Second object information is roll number is 20, name is Mahesh. Let us have one more object. S3 is equal to student of 30 comma Krishna. Now whenever object is created, then the control goes to the constructor. In S3 object, now roll number is 30, name is Mahesh. If we want, we can display here also. So print. So this is what? S3 object info slash n comma slash n roll number is display roll number. Here what is the object name? S3.rno comma slash n. Now let us display name. Name is colon. What is the object information? S3.name. Now save the program, Control S, and watch the output. So now what is S3 object information? Roll number is 30, name is Krishna. So in this way we can create parameterless constructor and parameterized constructor also. And one more important point here is constructor doesn't support overloading. In Python doesn't support constructor overloading. We know what is overloading. Defining the same constructor with multiple parameters. C++ and Java supports constructor overloading, whereas Python doesn't support constructor overloading. Let us define one more constructor with no parameter. Here, this constructor is not containing any parameter. So print zero constructor, and let us create an object for calling the zero constructor. Okay, so three objects are over. Let us create an object with the name S4. So let us write here. So S4 is equal to, what is the name of the class? Student. Here we have created this object for calling this constructor. Let us see what is the output. Here we got an error message, underscore init underscore takes one positional argument, but three were given. Why we got this error? Why? Because Python doesn't support constructor overloading. So we can't define multiple constructors with different arguments. That is not possible in Python. Whereas C++ and Java supports constructor overloading, but Python doesn't support constructor overloading. If we try to define multiple constructors with different parameters, then Python interpreter will use an error message. So this is about what is a constructor and types of constructors in Python program. In this video, we are going to discuss about inheritance in Python programming. First, let's see what is the definition of inheritance. Inheritance means the process of creating a new class from old class. So this old class is nothing but already existing class. If we create a new class from already existing class, that is old class, then this is called as inheritance. Inheritance means acquiring the properties of old class. Okay, here the old class is called as parent class, whereas new class is called as child class. Old class can also be called as base class. New class can also be called as derived class. Old class can also be called as super class. New class can also be called as subclass. Okay, so old class can be called as parent class or base class or super class, whereas new class can be called as child class or derived class or subclass. Acquiring the properties of base class is nothing but inheritance. So inheritance means creating a new class from old class. What is the major advantage of the inheritance? The major advantage of inheritance is reusability. Let the parent class contains three variables and two functions, whereas this child class contains, three functions. Here the base class contains only its members. So base class contains three variables as well as two functions, whereas this derived class contains its members as well as its base class members. So derived class contains its three functions as well as its base class members such as three variables and two functions. So these will be also available in derived class. So derived class contains its members as well as base class members also. The best example for inheritance is any human being. Any human being is the best example for inheritance. Why? Because we inherit our features and genetics from our parents, from our grandparents. So that's why we can say that any human being is the best example for the inheritance. Now let us see different types of inheritance in Python. Types of inheritance in Python. So mainly we have four types are there. First one is single inheritance. So first type of inheritance is single inheritance. Second one is multiple inheritance. Third one is multi-level inheritance. Let us discuss hierarchical. So third one is hierarchical inheritance. Fourth one is multi-level inheritance. So these four are the major types of inheritance. So what is the first one? Single inheritance. So first let us discuss about what is single inheritance. The name itself specifies the meaning. Single inheritance means we will have single derived class. This is the derived class. So single derived class as well as single base class. So the name itself specifies the meaning. Single derived class and single base class. So the process of deriving a single derived class from a single base class is called as single inheritance. Deriving a single derived class from a single base class is called as single inheritance. Let us see an example for this. Let we have a base class. Let name of the base class is base. Let B is uppercase letter. Let base class contains a method, a function. So def. Let name of the function is fun1. Of we know that every method in the class must contain selfie as the parameter. It ends with a colon. Next, let us write the body. So print. Let the body of this function is function1. Function1. Let us close the right parenthesis. Now let us derive a derived class. So class derived. Let name of the derived class is derived. Here we are creating the derived class by inheriting from the base class. So if we want to implement inheritance, then within the parenthesis we have to pass base class name. Here the base class name is base. So now derived class contains its own members as well as its base class member also. Base class contains a method called fun1. Now we can access the fun1 with the help of derived class object also. Okay. And now here define one more method, def fun2 of self. Let us provide the definition for the fun2. So print function2. Print function2. Now let us create by using object of base class, we can access only this base class function. Whereas by using the object of the derived class, we can access fun2 as well as its base class member also. Okay, that is the advantage of the inheritance. Derived class contains its own member as well as its base class member also. Let us create an object. Let name of the object is D. So D is equal to, what is the name of the class? Derived. Derived, left parenthesis, right parenthesis. Next, let us call the functions d dot fun1 next to d dot fun2. So whenever we call d dot fun1, then this function body will execute function1. Whenever we call d dot fun2, then fun2 function will be executed. Function2 will be executed. This is about single inheritance. Okay. Now let us see the second one. What is the second one? The second type of inheritance is multiple inheritance. What is single inheritance? Creating a derived class from a single base class. Whereas multiple inheritance means deriving a single derived class from multiple base classes. So multiple inheritance means we will have multiple base classes. 2 or more than 2 base classes. More than 2 or 2 base classes. Whereas we will have only one derived class. Okay. So let us see the diagram. So we will have multiple base classes. We will have multiple base classes. Let this is base 1. Let this is base 2. Likewise, we can have multiple base classes. Whereas we can have only one derived class. Only one derived class. So deriving a single derived class from multiple base classes is called as multiple inheritance. Now derived class contains its members as well as the members of base 1 and base 2 also. Now by using the object of the derived class, we can access its base class members also. Okay. So the first class is base 1. Let base 1 contains function 2. Now let us have one more base class. So class base 2. Here let us define second function def fun2. We need to pass selfie as the argument. Let body of this function is function 2. So print function 2. So base 1 and base 2 are the base classes. Now let us have the derived class. So class derived of. Now we are creating this derived class by inheriting from base 1 and base 2. So we have to pass base 1 and base 2 parameters. Okay. So it specifies that we are creating this class by inheriting from base 1 class, base 2 class. Now in derived class we can use the members of base 1 and base 2 also. So we can these two functions now will be available in derived class also. Def, let us have the body. Let name of the function is fun3. Self, we need to pass self as the parameter. So print, let body of the function is function 3. Now we need to create the object for the derived class. Okay, let us create object for the derived class. D is equal to derived. Now by using this D, we can access base 1 function, we can access base 2 function as well as derived function also. D dot fun3. Okay. Why? Because we have created object for the derived class. Now the derived class contains these three functions: fun1 function, fun2 function, fun3 function. If we call fun1 function, we will get message as we will get message as function1. If we call fun2 function, we will get message as fun2. If we call fun3 function, we will get message as function3. Okay. This is about multiple inheritance. Now let us see the next one, that is hierarchical inheritance. Hierarchical inheritance is an opposite to the multiple inheritance. In multiple inheritance, we will have multiple base classes and one derived class. Whereas in hierarchical inheritance, we will have only one base class and multiple derived classes. In hierarchical, we will have one base class and multiple derived class. One base class and multiple derived class. So we will have only in hierarchical inheritance one base class and we can have multiple derived classes. Let first one is derived 1, derived 2. Likewise, we can create a number of derived classes. So what is hierarchical inheritance? The process of deriving multiple derived classes from a single base class. The process of deriving multiple derived classes from a single base class is called as hierarchical inheritance. Now derived 1 class contains its members as well as base class members. Derived 2 class contains its member as well as its base class member. Now we have to create an object for the derived 1 class as well as an object for the derived 2 class. By using the object of derived 1 class, we can access this class member as well as its base class member. By using the object of derived 2 class, we can access this class members as well as its base class members. Here there is no relation between derived 1 and derived 2. Those two are different classes. So that's why we need to create object for both the classes. So now let us develop the program. So class. So what is the name of the base class? Base. So class base. Class base. Let us have a method. So def fun1 self. Let the body of the function is print function 1. Print function 1. Now let us create the derived class derived 1 of here we are inheriting from this base class. Now let us create function 2 fun2 of self, print of, let the body here is print of function 2. So now by using object of derived 1 class, we can access derived 1 class member as well as its base class member also. So we can access fun1 and fun2. Next class derived 2 of, we are creating this derived 2 class by inheriting from the base class. Now here let us have function 3. So def fun3 self, let the body here is print of function 3. Print of function 3. Now we need to create two objects. D1 is equal to derived 1. Next to D2 is equal to derived 2. So by using D1 we can access fun1 and fun2. So D1 dot fun1, D1 dot fun2. Now by using D2 we can access fun3 and fun1. So D1 dot fun1 and D1 dot fun3. D1 dot fun3. So likewise the appropriate messages will be printed. Function 1, function 2, function 1, function 3. Likewise we will get the messages. Now let us see the last one. The last type of inheritance is multi-level inheritance. Multi-level, the name itself specifies the meaning. What is the last one? Hierarchical is over. The last one is multi-level inheritance. In multi-level inheritance, we will have multiple levels are there. Let this level is grandparent level, this level is parent level, this level is child level. So grandparent level, parent level, child level. Here grandparent is the base class from which we derived the parent class. So this parent class is the derived class. So here we are deriving parent class from the grandparent class. So this will become the base class and this will become the derived class. Okay. Next, again we are deriving child class by inheriting from the parent class. Now this parent class will become the base class for this child class. So this child class is derived class. Okay. So here this parent class acts as derived class for the grandparent class, and this parent class acts as base class for this child class. So this is called as multi-level. Multi-level inheritance means the process of creating a derived class from another derived class. Here we are deriving child class from the parent class. Parent class is nothing but derived class only. Okay. Parent class is derived class only, but that acts as base class for this child class. Okay. So this is about multi-level. We will have multiple levels are there. Likewise, we can have n number of levels. There is no problem. So this is called as multi-level. So let us have an example for this. And after that, we are going to execute practically in the computer. So class, let the first class name is grandparent. Let in this G and P are uppercase letter. Let us define the function. So def fun1 of self, print of function 1, print of function 1. Next, let us create parent class from grandparent class. So we have to pass grandparent as the argument. Let us have fun2 function here. So fun2 of self, print of function 2, print of function 2. Now this parent class contains fun2 as well as fun1 also. Okay. Why? Because it is inherited from the grandparent class. Next, class child of parent. Here we are creating the child class by inheriting from the parent class. Now child class contains fun1, fun2, okay, as well as its function also. Let its function is fun3. So define fun3 of self, print of function 3, print of function 3. Here parent class contains fun1 and fun2. Here we are deriving the child class by inheriting from the parent class. Parent class contains two functions such as fun1 and fun2, and child class contains fun3. Now we have to create an object for the child class. Now by using that object we can access those three functions. Let object name is C. So C is equal to child. So C dot fun1, C dot fun2, C dot fun3. Okay. Likewise, we can implement multi-level inheritance. Now let us see practically. Now let us see the practical implementation. So new file. First let's see the program for single inheritance. Single inheritance. We know that we can give comments by using hash symbol. Let us create the base class. Let name of the base class is base colon. Let define one function def. Let name of the function is fun1. We must pass selfie as the parameter whenever we want to define a function in the class. Let the body of this function is so print of function1. Print of function1. Now let us define the derived class. So class, let name of the class is derived. We have to pass base as the parameter because this is the derived class. Now let us define fun2. Def fun2 of self. So let the body of this function is print of function2. Function2. So now derived class contains fun1 as well as fun2. By using the object of the derived class, we can access both fun1 as well as fun2 also. An object is created for the derived class. So d dot fun1, d dot fun2, d dot fun2. Now let us save the program. Alt F, save as some INH inheritance. Let us run the program F5. So we got the output as function1 and function2. That means by using the derived class object, we accessed both derived class function as well as the base class function. Now let us see the second type of inheritance. The second type of inheritance is multiple inheritance. In multiple inheritance, we will have two base classes. Let us create another base class. We will have two base classes. Class, let name of the first base class is base1. Now let us create base2. So class base2 def fun2 of self print function2. Now we have to create the derived class by inheriting from base1 and base2. Base1 and base2. Let this function name here is 3. Change the body to function3. Now by using the object of the derived class, we can access fun1, fun2, fun3. Why? Because here derived class is created by inheriting from two base classes, fun1 as well as fun2. So d dot fun1, d dot fun2. We can access fun3 also, d dot fun3. Let us save the program, Ctrl S, run it F5. So we got the message as function1, function2, function3. That means multiple inheritance is also working properly. Now let us see about hierarchical inheritance. Hierarchical inheritance is opposite to the multiple inheritance. Here we will have only one base class. We will have only one base class and we will have two derived classes. Creating multiple derived classes from a single base class. So derived one of base. Likewise, let us create derived 2 class by inheriting from the base class. Now we have to create two objects. So first object for derived 1 class, second object for, let here the name is d1, second object for derived 2 class. So derived 2. Now by using derived 1 class object, we can access fun1 as well as fun2. And by using derived 2, we can access fun1 and fun3. So let us access fun1, d2 dot, let us access fun3. So d1 dot fun1, d1 dot fun2, d2 dot fun1, d2 dot fun3. Ctrl S, F5. If we observe here, function1, function2, function1, function3. So hierarchical inheritance is also working properly. Let us see the last type of inheritance, that is multi-level inheritance. Multi-level inheritance. So instead of methods, we can also use variables. So in multi-level inheritance, we will have different types of levels. Let the first level is grandparent level, grandparent, and the second level is parent level. So we have to derive the parent class by inheriting from the grandparent class. By inheriting from the grandparent class. Now we have to create the child class by inheriting from the parent class. So here parent class contains its member as well as its base class member. So parent class contains fun1 and fun2 functions. Here child class is created by inheriting from the parent class. So now child class contains its member as well as its base class member. That means it contains function1, function2 and function3. Now we need to create object for the child class. So let us create the object. Let name of the object is D. So D is equal to child. Now by using D, we can access fun1, fun2, fun3. So D dot function1, D dot function2. Likewise, we can access D dot function3 also. D dot function3. So control S. Let us run the program. So we got the output as function1, function2, function3. So this is about types of inheritance in Python programming. In this video, we are going to discuss about constructors in inheritance in Python programming. We know what is a constructor and inheritance. Constructor is mainly useful in order to construct an object, in order to provide initial values to the object. We have two types of constructors are there: parameterized constructor, parameterless constructor. Parameterless constructor means the constructor without any parameters. Parameterized constructor means the constructor with parameters. There is no need to call the constructor explicitly. Whenever an object is created, then automatically the constructor will be called. We know what is inheritance. Inheritance means creating a new class from the old class. So now the new class acquires the features of the old class. We have different types of inheritance are there: single, multiple, multi-level, hierarchical. The major use of the inheritance is reusability. We can use the members of the base class in derived class without declaration. Without redeclaration, we can make use of base class members in the derived class. So that is reusability. In this video, we are going to discuss about how to use constructors in inheritance, how to pass parameters to the base class constructor from the derived class. That can be done with the help of the super keyword. So how to use super keyword in order to call the super class constructor, how to use super keyword in order to call the super class method. All those things will be discussed in this video. So first let us create two classes. One is base class and another one is derived class. So let we have a base class. So class, let name of the base class is B, base. So in base, let us assume that this B is uppercase letter. Now let us define a constructor in the base class. We know how to define a constructor by using def keyword, def space, underscore, underscore, init. So init method is nothing but constructor, underscore, underscore. Within the parenthesis, we must pass self as the parameter, comma. Let us assume that base class constructor contains two parameters. Let the first parameter is roll number. Let the second parameter is age. So colon. Next we have to perform the initialization. We know that in class in Python programming, there is no need of any declaration. We can use the self keyword in order to perform the initialization. So self dot roll number is equal to roll number. Next self dot Age is equal to years. Okay. So here we have a base class which contains a constructor. Now let us define the derived class. So class, let name of the derived class is derived. In derived, let D is uppercase letter. Here this is nothing but inheritance. Okay. So how to implement inheritance in Python programming? We have to pass the name of the base class within the parenthesis. So what is the name of the base class? Base. So we have to pass that base class name within the parenthesis. Okay. Now let us define a method. Initially don't define any constructor here. So def, let name of the method is display. We must pass self as the parameter. Let us display roll number and the name. So print of self dot roll number comma self dot name. Self dot roll number comma self dot name. Okay. Here this is nothing but derived class which is inheriting from the base class. So whenever derived class is implemented, then in derived class we can use all the attributes of the base class. Here what are the attributes of the base class? Here we have roll number and age. We can make use of base class members in derived class also. Now the derived class contains roll number as well as name, and it contains one method. Okay. Now let us create an object. In inheritance, generally we will create an object for the derived class only. Okay. Let name of the object is D. So what is the name of the class? Derived. So D is equal to derived. So here we have to pass two parameters. So what is the first parameter? Name of the first parameter is roll number. Name of the second parameter is name. So let the roll number is 72. Let the name is Ramesh. We know that name is a string. It is enclosed in quotations, either single or double quotation. Now let us call the display method. So D dot display. So here an object is created for the derived class. So 72 comma Ramesh. So the control goes to the derived class. We know that whenever an object is created, then automatically the constructor will be invoked. But here derived class doesn't contain any constructor. So now the control goes to the base class constructor from the derived class. Here let us display one statement. So print of. So this is nothing but base class constructor. We know that base class can also be called as super class also. So let us display the message as super class constructor. So whenever this object is created, then super class, then whenever this object is created, then subclass constructor will get invoked. But here subclass doesn't contain any constructor. So the control will goes from this subclass to the superclass constructor. Here we have a superclass constructor. So this body will get executed. So we will get the message as superclass constructor, and once the execution is over, then the control comes to the derived class. After that the control comes to the next statement. Okay, next statement after this object creation. Now what is the value of the roll number? 72. This 72 will be stored in the roll number, and this Ramesh will be stored in, so I'm sorry, here we have name. So roll number comma name. So self dot name is equal to name. Self dot name is equal to name. Now roll number contains 72, name contains Ramesh. Next D dot display. So derived class display method will get invoked. Display, print of self dot roll number comma self dot name. So what is roll number? 72. What is name? Ramesh. So that will be printed. Superclass constructor, and then 72 space Ramesh will be printed. Now let us assume that subclass, that is derived class, also contains a constructor. Let us assume that here derived class also contains a constructor. So def underscore init of self comma, let it contains its parent class members. What are its parent class members? Roll number comma name. Let derived class member is age. So def underscore underscore init underscore underscore of, we must to pass self as the parameter, comma, this roll number and name are nothing but its parent class members, whereas age is nothing but this derived class member. Okay. Now let us perform the initialization. So self dot roll number is equal to roll number. Next self dot name is equal to name. Self dot name is equal to name. Next self dot age is equal to age. Self dot age is equal to age. Okay. So here we have defined a constructor here. Let us display some message here. Print of. So this is nothing but subclass constructor. So print of subclass constructor. Okay. Next, in addition to roll number and name, let us pass age. Let age is 35. Now let's see how the program will get executed. D is equal to derived of 72 comma Ramesh comma 35. So whenever an object is created, then automatically derived class constructor will get invoked. Here we have derived class constructor. So this constructor will be executed. So what is the roll number? 72. Now roll number contains 72. Name contains Ramesh. Age contains 35. Next print of subclass constructor. So print of subclass constructor. Now we will get the message as subclass constructor. After that, control comes to the next statement after the object creation. D dot display. So control goes to the display method. So now this message will be printed. 72, Ramesh 35. So in this occasion, this superclass constructor will not be executed. So here the problem is, if superclass as well as subclass contains a constructor, and if we create the object, then only this subclass constructor will be invoked. This superclass constructor won't be executed. So in this type of situation, how to execute superclass constructor? That should be done with the help of the super keyword. Here we have a statement called, for space constraints I am writing here. Later we will see practically, there you will get the perfect clarity if you have any doubts. So super dot underscore underscore init of what are the parameters of the superclass? Roll number and name. So we can pass those parameters. So roll number comma name. So super, we have to use super keyword here. So super left parenthesis right parenthesis super dot, what is the constructor name? Underscore underscore init underscore underscore of, it contains two parameters. So we have to pass those parameters. So now whenever this constructor is executed, then what is the statement here? We have super dot underscore underscore init of roll number comma name. So now whenever this statement is executed, then superclass constructor will be executed. Okay. So we will get the message as superclass constructor. Next to some initializations will be done, and after that here these initializations will be done. Next to print of subclass constructor. So all those messages will be printed now. Okay. In this example, if we observe here, self dot roll number is equal to roll number, self dot name is equal to name. Here also we have self dot roll number is equal to roll number, self dot name is equal to name. We can eliminate these two statements now. Why? Because here we passed those parameters from this constructor, from this function call. So now there is no need of these two initializations. That is the advantage of the inheritance, reusability. Already roll number and name are nothing but parent class members. Already initialization was done there. So here there is no need of doing any initialization. Now let us have a method here. So def display, instead of display we can use some other name also. So self, let us display roll number and name here. Self dot roll number comma self dot name. Now there is no need to display roll number and name here. Let us display only print of self dot age. Let us display only age here. Here if we want to call superclass method from the subclass, we can use a statement called super dot name of the method. Let name of the method is dis. Then we can write as super dot dis. Okay. Now let's see how the program will get executed. D is equal to derived of 72 comma Ramesh comma 35. So whenever this statement is executed, then superclass constructor will be executed. Here we have the superclass constructor def underscore underscore init. Here we have superclass constructor. Here we uses this statement super dot underscore underscore init underscore underscore of roll number comma name. So whenever the statement is executed, then its superclass constructor will be called. So now this constructor will be called. So superclass constructor, we will get this message. Next, roll number initialization and name initialization was done. What is roll number here? What is roll number? 72 and Ramesh. Now roll number contains 72, name contains, now roll number contains 72, name contains Ramesh. Then after that, remaining statements are executed. Self.age is equal to age. What is the age? We passed 35. Now age contains 35. Print of subclass constructor. So subclass constructor will be displayed. That message will be displayed. And what is the next statement after the object creation? D.display. Here the object is D, derived class object. So this display method will be executed. Print of self.age. What is age value? 35. So 35 will be printed. Next, super.dis. Whenever the statement is executed, now its superclass dis method will get executed. Now this method will get executed. Roll number is 72. That message will be printed. Name is Ramesh. That message will be printed. So this is the use of super keyword as well as constructors in inheritance. So there are mainly two uses of super keyword. The first use is by using super keyword, we can call superclass constructor, and we can also pass parameters to the superclass constructor. And the second advantage is by using super keyword, we can call the superclass method. In Java, by using super keyword, we can access superclass variables. But in Python, that is not possible. By using super keyword, it is not possible to access the superclass variable. So this is about constructors in inheritance. Now let us see the practical implementation. Now let us see the implementation part. So what is the name of the program? Constructors in inheritance. So how to use constructors while implementing the inheritance. So first let us have the base class. So class, let name of the base class is base. Now let us define the constructor. Def space underscore underscore init underscore underscore. In constructor we must pass self as the parameter. It has two parameters, roll number and name. Now let us do the initialization. Self dot roll number is equal to roll number. Self dot name is equal to name. So constructor is over. Base class is over. Now let us have the derived class. So class derived. Here we are implementing the inheritance. So we must pass base as the argument. Now here define the display method. So define display of. Method means we must pass self as the parameter. Here we are implementing the inheritance. So in derived class we can use roll number and name. So print of self dot roll number. Next to print of self dot name. Now here we are implementing the inheritance. It is better to create an object for the derived class. D is equal to derived of. We must pass two parameters. First one is some integer number. Some number. Second one is some string. Now let us call the display method. So d.display method. Now let us save the program. So let name of the program is some constructors con. Constructor, save the program, save. Now let us run the program, F5. So we got the message as 72 Ramesh. Here there is no problem. Why? Because here derived class doesn't contain any constructor. So whenever an object is created, then control goes to the derived class constructor. But in derived class we don't have any constructor. So the control goes to the base class constructor. Now roll number is 72, name is Mahesh. Okay. Now this is derived class. Now in derived class we can make use of the base class members. So we can print roll number and name now. So now there is no problem. Now let us assume that derived class also contains a constructor. Control C. Let us define a constructor in derived class also. Here this roll number and name are nothing but its base class members. let us have one more member A's. A's is nothing but its own member. So self dot A's is equal to A's. Self dot A's is equal to A's. Self dot A's is equal to A's. Now in order to know which class constructor executed, let us display the message print of. This is nothing but superclass constructor message, superclass constructor body. Likewise, let us display a statement in subclass also, so that we can get the clarity about which class constructor has got executed. So this is nothing but subclass constructor, subclass constructor, subclass constructor. Now let us save the program and run it. Yeah, we forgot to write so subclass constructor. So print of subclass constructor self dot. Let us see what is the error here. In it missing one required positional parameter called A's. Here we missed one parameter. Here we need to pass A's also. Let A's is 35. So Control S. Now let us run the program. F5. So here subclass constructor. Here only subclass constructor got executed. Superclass constructor is not executed. That is the problem here. So how to call the superclass constructor? In order to call the superclass constructor, we can use super keyword. Super, we must use left parenthesis, right parenthesis, dot. What is the name of the constructor? Underscore, underscore, init, underscore, underscore. Here we have to pass parameters to the superclass constructor. What are the parameters we need to pass? Roll number, comma, name. So roll number and name are nothing but superclass parameters. Control S. So now whenever the statement is executed, then superclass constructor will get executed. So first we will get superclass constructor as the message. Next we will get subclass constructor as the message. Next roll number and name will get printed. If we display the message here, first we got superclass constructor message. Next to subclass constructor message. Next to 72 Ramesh. Here already we performed the initialization, roll number initialization and name initialization in superclass constructor. So there is no need to do that initialization in the subclass. We can eliminate those two statements. So here we have eliminated those statements. So self dot A's is equal to A's, Control S. Now let us run the program. Okay, we got the output. Okay, so there is no problem if we eliminate those statements. Now let us have display method in superclass also. Def. Let us assume that here name of the method is dis. So self here display roll number and A's, because roll number and roll number and name are nothing but the members of the superclass. So self dot roll number, comma self dot name. Okay. Now here display only A's, because A's is nothing but this class member. A's is nothing but this class member. So self dot A's. So how to call the superclass method from the subclass? So that should be done with the help of the super keyword. So super dot, what is the name of the method? Dis. So here roll number and name was displayed in superclass, as well as whereas this A's was displayed in this display method of the subclass. Now let us run the program. So there are no problems. We got the message as superclass constructor, subclass constructor, 72 Ramesh, 35. So in this way we can use constructors in inheritance in Python programming. In this video, we are going to discuss about encapsulation in Python programming. First, let us see the definition of encapsulation. Encapsulation means the wrapping of variables and functions under a single unit called class. Under a single unit called class. So what is encapsulation? The wrapping up of variables and functions under a single unit called class. Wrapping means combining. Combining variables and functions is called as encapsulation. If you place variables and functions in a class, then it is called as encapsulation. The major advantage of encapsulation is data hiding. We can achieve data hiding with the help of the encapsulation. So data hiding means we can use the variables and functions of a class only inside that class only. We can't use variables and functions from outside the class. Okay. For that we use private. So we use private access specifier in order to implement the data hiding. Now let us see an example program. Let we have a class called Encap. Encap is the name of the class. Let here we have a variable called A whose value is 10. Whose value is 10. Okay. Next, let us define a function. So def, let name of the function is display. We must pass self as the parameter. Let us display a value now. So print of, here a is some instance variable. So we must use self in order to access that variable. So print of self.a. Now let us create an object for the class. So E is equal to encap. Now with the help of the object, use display method as well as we can access that variable also. So print of E dot A. Here name of the class is encap. A is 10. Okay. Here here there is generally in order to specify private variables we uses double underscore symbol. Here there is no double underscore symbol. If there is no symbol, then by default the variable will become the public variable. Here also there is no symbol before the display method. So this method is also public method. So here this is public variable and this is public function. We can access public variable and public function from anywhere in the program. So we can access these two within the class as well as from anywhere in the program. We can access A and display because they are public members. Okay. So print of self.a. Here an object is created for the class e.display. So whenever the statement is executed, control goes to the display method, print of self.a. So what is a value? 10. So 10 will be printed, and after that print of e.a. Here this A is the public member. We can access this member from anywhere in the program. So print of e.a. So what is a value? 10. So 10 will be printed twice. Now in order to provide the data hiding, we have to use private access specifier. But Python doesn't support private access specifier. If we want to make a variable or a function as a private, then we must use two underscore symbols. So let us use two underscore symbols before the A. So underscore A is equal to 10. Now this A will become the private variable. We know that we can access the private variable only inside the class. From outside the class, it is not possible to access the private variable. So now we can write the statement as print of self dot. Before A we have to use two underscore symbol. So self dot underscore A. Okay. So there is no problem. Why? Because this display is nothing but this function only, this class function only. So this function can access the private data. Okay. The private variables are accessible by public function of the same class. Public function of the same class. Here this display is nothing but public function. So there is no problem. E.display, we can access the display function. Why? Because display is nothing but public function only. But the statement is wrong. Why? Because here A is defined as what? Private variable. We can access private variable only inside this class. So we can't access this A from outside the program. So if we write this statement, then the compiler will give error message. Okay. Then Python interpreter will give error message. So e.display method, control goes to the display function, print of self dot underscore A. So what is A value? 10. So we will get 10 as the output. If we want, we can make this display as private also. So how to make this display as private function? By placing two underscore symbols before the display function. Okay. Now can we call this method like this? E dot underscore underscore display. We can't call display function from outside the program now, outside the class now. Why? Because display is defined as private function. We know that we can access private function only within the class. We can't access private function from outside the class. So if we try to call display method like this, then the Python interpreter will use error message. So in order to overcome that problem, we have to define one more function. Let this function is public function. Let this function is public function. This is public function. Why? Because there is no symbol before the show method. Now from this public function, call the private function. So we can call like this: self dot underscore underscore display underscore underscore display. We can call private member function from the public member function of the same class. So there is no problem. Okay. Now from outside the class, let us have the object is equal to encap. Now which function we have to call? Now we have to call the public member function. Here show is nothing but public function. So let us call the show function e dot show. So e dot show. So whenever the statement is executed, control goes to the show function. From the show function we called private display function, this display function. So whenever the statement is executed, control goes to the display function. So print of self dot a. So 10 is printed. Okay. Here in order to access this private member variables, we can use setter and getter methods. We can use setter methods and getter methods in order to perform operations on private variables. Setter methods are useful in order to set the value, in order to initialize the value, whereas getter methods are useful in order to get the value, in order to return the value. Now let us define one setter function and one getter function. Let us define those functions as public functions so that we can call them from outside the program. Okay. So this is setter function. So def, let name of the function is set a. So set a. We must pass self as the parameter. Let the second parameter is b. So what is the use of setter functions? By using setter function, we can set the value, we can initialize the value, we can change the value. So here this a is nothing but instance variable. So we must use self. So self dot, this is private variable. So underscore underscore a is equal to, let us change the value by performing some addition. Self dot underscore underscore a plus, but this b is nothing but local variable of the set a function, whereas underscore underscore a is nothing but instance variable. We can access the local variable directly by using the variable name. We can access the local variable. There is no need of self. B is the local variable of the set a function, so directly we can use only b. There is no need of self. Okay. Now let us have the getter method. Getter methods are useful in order to return the value. So let name of the function is get a. So we must pass self as the parameter. Getter method doesn't contain any parameter except the self. Okay. So from this method, let us return the value. So let us return the value self dot underscore underscore a. Underscore underscore a. Now let us call setter method as well as getter method. So e dot set a of, let us pass 30. Next, for getter method, it returns the value. So we need to print that value. So print of e dot get a. Okay. Here an object is created. Here set a and get a both are defined as public functions. So we can call them from outside the program. There is no problem. E dot set a of 30. So whenever the statement is executed, control goes to the set a function. What is the value? 30. So 30 will be passed to b. So self dot underscore underscore a is equal to self dot underscore underscore a. What is the value of a? 10. So 10 plus, what is the value of b? So 10 plus 30 means 40. Now this underscore underscore a, this private variable contain a value called 40. Next, print of e dot get a. Whenever this statement is executed, control goes to the get a function. Return self dot underscore underscore a. What is the value of underscore underscore a? 40. So that 40 will be written and it will be printed here. So likewise, we can perform operations on the private variable by using the setter and the getter method. So this is about encapsulation in Python programming. Now let us execute all these programs practically. Now let us see the practical implementation. Let we have a class called encapsulation. Let name of the class is encap. Let we have a variable called a whose value is 10. There is no symbol before a, so this is public variable. Likewise, let us define the function def. Let name of the function is display function. Let us pass selfie as the parameter. We must pass selfie as the parameter. Here in order to, if we want to access a is instance variable, so we must use self. So now both a and this is called as encapsulation. Encapsulation means wrapping variable and functions under a single unit called class. Now this class encapsulation contains a and display. So that's why we are calling this as encapsulation. Now we need to create an object e is equal to encap. Now let us call the display function e.display. E.display. Control S. Let name of the program is encapsulation. Encapsulation. Let us run the program F5. So we got output as 10. If we want, we can access that a from outside the program also, from outside the class also. Why? Because a is public variable. So print of e.a. Now we will get 10 two times. So now that 10 was printed 2 times. Okay. Now let us make this variable as private variable. So how to make a variable as private? By keeping 2 underscore symbols before the a. Now if we want to access that a, we must use 2 underscore symbols. Here display function is nothing but function of this class only. So we can access private variable from the function of the class. There is no problem. Here this display is what? Public function only. So we can access them from outside the program, from outside the class. F5. We got an error message. So why we are getting error message? Because of this statement. Print of e.a. But a is declared as private variable. We can't access private variable from outside the class. So let us place this statement in comment. Control S, F5. So now we got 10 as the output. 10 as the output. Let us define this function as a private function. So we need to place 2 underscore symbols. Now let us call the display function. Now the program will produce us error message. Why? Because now display function is defined as private function. We can't call the private function from outside the class. If we try to call the private function from outside the class, then Python interpreter will give error message. Now we got the error message. In this situation, what we can do is, let us define a public function. So def show self. Now let us call the display function from this self function. So self dot underscore underscore display. Self dot underscore underscore display. Here show is the public function. Now let us call the show function from outside the class. E dot show. Control S. Now there is no problem. So we got the output. We got the output as 10. Show is the public function. So whenever the statement is executed, control goes to the show function. From the show function, we call the display function. So control goes to the display function and the value of a is displayed. In order to access private member variables, we can use setter method and getter method. So def set a, so self comma b. Setter methods are useful in order to set the value, in order to change the value. So self dot underscore underscore a is equal to, just I am performing some addition operation. Self dot underscore underscore a plus, here this b is nothing but local variable of the set a function. We can access the local variable directly. There is no need of the self. In order to access instance variable only, we must need self. So we can access directly. Likewise, define the get function, getter method. So def get a. Getter method doesn't accept any parameter other than self. So for by using getter method, we can return the value. So return, let us return self dot a value, self dot underscore underscore a. Now let us call getter method and setter method. So e dot set a, setter method means we must pass one value. Let us pass 30. Getter method means let us display the result. So print of, call the method in the print. So e dot get a. So 30 will be passed to the b. So now self dot underscore a is equal to self dot underscore a means 10. So 10 plus 30 means 40. Now we got output as 40. Now we will get output as 40. Yes, we got output as 40. So this is about encapsulation in Python programming. In this video, we are going to discuss about types of variables and methods in Python programming. Python mainly supports 3 types of variables and 3 types of methods. The variables supported by Python are instance variables, static variables, local variables. And we have 3 types of methods are there in Python: instance methods, static methods, class methods. First, let us discuss about instance variable. So what is an instance variable? Instance variable means if the value of the object changes from one object to another object, then we can make use of the instance variable. Let us see this example. Here name of the class is student. Here we have a constructor. Constructor accepts 3 parameters: self, roll number, name. So self is compulsory. So we need to pass roll number and the name. And here we have a statement: self dot roll number is equal to roll number. This statement is called as, this is called as instance variable. Self dot roll number is called as instance variable. Instance variables are always accessed by using self. Here this roll number and name is nothing but argument of the method. So these are called as local variables. We will discuss that in the local variable concept. So how to access the instance variable? Instance variables are always accessed using self keyword. In place of self, we can use some other keyword also. There is no problem. So self dot roll number, self dot name. So this is nothing but some display method. This is also instance method. So here also self dot roll number is instance variable. Self dot name is instance variable. So let us see the program. S1 is equal to student of 72 comma Ramesh. S1 is the object. Let us see S2 object. S2 object content is 73 comma Mahesh. Here when we can use instance variable, if the value of the variable changes from one object to another object. Here the first object roll number is 72. Second object roll number is 73. So the value of the variable changes from one object to another object. So in this occasion we have to use the instance variable. Next, the value, if we consider the name of the first object is Ramesh. Name of the second object is Mahesh. So the name changes from first object to second object. In this occasion we have to use the instance variable. So what is the need of instance variable? If the value of the variable changes from one object to another object, then we can make use of the instance variable. And how to access the instance variable? We can instance variables are accessed in a constructor or in a method. So they are accessed by using the self keyword. Okay. So what is the output of this program? What is the first object content? 72 Ramesh. So S1 is equal to student of 72 comma Ramesh. So whenever an object is created, automatically constructor will be invoked. So this is the constructor. 72 will be passed to the roll number. Ramesh will be passed to the name. So self dot roll number is equal to 72. Self dot name is equal to Mahesh. So first object information is 72 Mahesh. S1 dot display. So control goes to the display function. So now self dot roll number and self dot name will get displayed. So what is the output now? We will get output as 72 Ramesh, 72 space Ramesh. In the second line 73 space Mahesh. We will get an output like this. Now let us see about instance method. What is the purpose of the instance method? Instance method is mainly useful in order to access the instance variable. So that's why here in instance method we must pass self as the argument. In place of self, we can pass some other argument also, but it should contain one argument, self. Okay. So this is the instance method. Okay. Instance method is useful in order to access the instance variable. Self.rule number, this is instance variable. Self.name, this is instance variable. Rule number and name are nothing but instance variable. So that's why we are accessing them with the help of the self keyword. And one more important point is instance method is also useful in order to access the static variable. So by using instance method, we can access static variable also. How we can access the instance method? Instance method is always accessed by using object s1.display, s2.display. Why? Because instance variable is called as object level variable and instance method is called as object level method. Object level method. Why? Because each object has its own copy of the variable. Here S1 object contains its own copy of the data, 72 Ramesh. S2 object contains its own copy, 73 Mahesh. Each object contains its own data. So that's why we must use an object in order to access the instance method. Now let us see the next one. The next one is static variable. What is a static variable? If the value of the variable is same for all the objects, then we have to use the static variable. So static variable means common variable, shared variable. All the objects of the class will make use of that variable. Here let we have 100 students in this program. Let all the 100 students are belonging to the same university. So university is same for all the objects. In that occasion, we have to declare that variable as static variable so that all the objects can perform operation on that variable. If one object modifies that data, that information will be reflected to remaining all other objects also. Okay. So where we have to declare the static variable. Static variables are also declared inside a class only, but outside constructor and methods. Generally, static variables are declared on top of the constructor and methods. Okay. Here let name of the static variable is university, UNIV is equal to, let university name is XYZ, XYZ, XYZ. So now all the objects of the class can access university. So UNIV is equal to XYZ. Now let's see how to access the static variable. Here static variables are associated with class rather than object. Why? Because the complete class, all the objects of the class can access that variable. So that's why we can say that static method is called as, we can call this method as class level method also. Why? Because all the objects can perform operation on that variable, and this static variable can also be called as class level variable. Class level variable. Why? Because in the entire class we can make use of that variable. Okay. Now let's see how to access the static variable. In order to access the static variable, we have to use the class name instead of object. Instead of object, let us display that information here. So print of, what is the name of the static variable? University. And what is the name of the class? Student. So print of student dot UNIV. Student dot UNIV. So class name dot static variable. So this is about what is a static variable. Okay. So what is the output for this program now? So whenever we call this method s1.display, now then what will happen? First roll number 72 printed, next name Ramesh will be printed, and after that what is the name of the university? XYZ. So XYZ will be printed. And after that, whenever S2 object is created, after that we call display method. Then roll number is 73, name is Mahesh. What is student.university? What is the university name? XYZ. So XYZ will be printed. The university is same for all the objects. So this is about static variable. Now let us see about static method. What is the use of a static method? By using static method, we can access only static variable. By using static method, it is not possible to access the instance variable. Whereas by using instance method, we can access instance variable as well as static variable also. By using instance method, we can access, this is instance variable, this is static variable. Whereas by using static method, we can access only static variable. Now let us define the static method here. Here, in order to define the static method, we have to use a decorator called @static method. This is called as decorator, symbol, decorator, static method decorator. Now let us define the static method. Def, let name of the static method is show. Static method doesn't accept any parameter. Here self is not needed. So that's why in static method it is not possible to access the instance variable. Why? Because we know that instance variables are accessed by using the self. But here self is not there. So there is no need of self here. Static method means we must write @static method on top of this declaration. Next, here what is the name of the class? Student. So student dot univ is equal to, let name of the university is some JNTU. Let us print that data. So print of student dot university. So by using static method, we can access mainly static variables. Okay. So print of student dot university. Now let us call that static method. How to call the static method? Just like the static variable only. Class name dot method name. So here what is the name of the class? Student. So student dot, what is the name of the method? Show. Student dot show. So whenever the statement is executed, control goes to the show method. Now what is the university value? Previously university value is XYZ, but now it is changed to the JNTU. So print of student dot university means JNTU. Here if you want, we can perform initialization in constructor also. Like, so how to access the static variable? Student dot university is equal to, let the value is some ABC. So we can do the initialization here also. Okay. But we must use the class name in order to access the static variable. Let us put the statement in the comments. If you want, we can use this statement also. So this is about static method. Now let us see the last type of variable, that is local variable. What is local variable? Local variable means the variables which are declared inside a function, inside a method. So in this program, this roll number and name is nothing but, in this function, in this constructor, this roll number and name is nothing but local variable. So we can make use of this roll number and name inside this constructor only. Okay. So this roll number is nothing but local variable. This name is nothing but local variable. Local variables are always useful for temporary calculations. Okay. If we want, we can declare a local variable. A is equal to 10. So this is the local variable. Whenever we declare a variable inside a method, this is called as local variable. We can access the local variable directly by using the variable name. There is no need of any object. Here this self is not needed. Self dot roll number, that is not needed. Why? Because this is a local variable. This name is also a local variable. What does this roll number and name contain? For the first object, roll number is 72, name is Mahesh. For the second object, roll number is 73, name is Mahesh. Okay. So these local variables are useful for temporary calculations, for temporary storage. We use the local variable. So we can access this variable directly. There is no need of any object. Now let us see about the last one, that is class method. So what is a class method? Class method is mainly useful in order to access class level variable. So just like the static method, by using class method also we can access the class level variable. But the way of accessing is different. So let us see that. So class method means we must use the decorator @class method. @class method. Next, def. Let name of the class method is C method. Def C method. Class method means we must pass an object as the argument. CLS stands for class level object. So whenever a class is declared, here the class is student. For the entire class, an object is created. So that object is nothing but CLS, class level object. Okay, the student class object. In place of CLS, we can use some other name also. There is no problem. Okay, we can use Ramesh, Naresh, self. We can use any other argument. So the CLS means what? Class level object. Now we can access this class level variable with the help of the CLS. Okay, so CLS dot, what is the class level variable here? What is the static variable? University. So CLS dot university is equal to, let name of the university is Oxford. Next to print of cls dot university. Here class method means we must use the decorated @ class method, and it should accept a class level object as the argument. Now we must use this class level object in order to access the static variable. Whereas static method means it doesn't contain any argument here. Okay, it doesn't contain any argument. In order to access, we use the class name. But here we have to use the class level object. And the way of calling the class method is also similar to the static method only. Class name dot method name. What is the name of the class? So student dot, what is the name of the method here? C method. Student dot C method. There is no need to pass any argument. So whenever this statement is executed, control goes to the C method. So now university changed to the Oxford. Print of cls dot university means we will get the message as Oxford. So this is about instance variable, static variable, local variable, instance method, static method, class method. So I will revise once regarding what is the use of each and everything. So what is the use of instance variable? When we can use instance variable? If the value of the variable changes from one object to another object, we use as the instance variable. How to access the instance variable? By using the self word, self keyword, self dot roll number, self dot name, likewise. Okay. Next, what is instance method? Instance method is mainly useful in order to perform operation on instance variable and static variable. Instance variable and static variable. How to call the instance method? By using object dot that method name. Now what is static variable? Static variable means if the value of the variable is fixed for all the objects. That means if all the objects of the class wants to perform operation on a single variable, on a shared variable, then we have to go for the static variable. Where we have to declare the static variable? Inside a class only, but outside the constructor and all the methods. Generally static variable is declared on top of the constructor and the method. Next, how to access the static variable? By using class name dot that variable name. Next, what is the purpose of static method? Static method is mainly useful in order to access the static variable. We can't access instance variable in the static method. So static method means we must use the decorated @ static method, and it should not contain any argument. How to call the static method? By using class name dot method. By using class name dot that static method. Next, what is local variable? Local variable means the variables which are declared inside a function. They are useful for temporary calculations. We can access the local variable directly by using the variable name. There is no need of any object like self. Next, what is the use of class method? The functionality of the class method is also similar to the static method only. It is also useful in order to access the class level variable such as static variable. But here static class method means we must use the decorated @ class method, and here the argument is class level object. Class level object. Now in order to access the static variable such as class level variable, we must use this class object. How to call the class method? By using class name dot that method name. Now let us see the practical implementation. Now let us see the program execution. So class, let name of the class is student. First define the constructor def space underscore underscore init underscore underscore of. We must pass self as the parameter. Let the remaining parameters are roll number and name. Here roll number and name are nothing but local variables. Function, the variables which are declared in a function, they are local variable. Here the function is nothing but that constructor. Now self dot RNO. This is called as instance variable. Instance variables are accessed by using self keyword. Next self dot name is equal to name. So right hand side variables are local variables. Left hand side is nothing but instance variable. Let us define the function in order to display the data. So def display of self. Let us display the data. Print of self dot roll number comma self dot name. Now let us here this method is what? Instance method. Why? Because this method contains self. Instance method is mainly useful in order to access the instance variable. So roll number and name are instance variables. Now let us create two objects. So S1 is equal to student of Let the first object roll number is 72. Name is some Ramesh. So first object content is 72 Ramesh. Let us call the display method. So we can call the instance method with the help of the object. Now let us have the second object. S2 is equal to student of, let the roll number is 73. Name is Mahesh. So second object content is 73 Mahesh. Now let us call the display function. S2.display. Now let us run the program. So here we got an error. STDNT. So some spelling mistake is there. STU. Let us run the program. So 72 Ramesh, 73 Mahesh. So we got the output. Now let us do the initialization. Okay. Now let us see about static variable. So how to declare a static variable? It is declared inside a class and on top of all the methods. Let the static variable is university is equal to, let name of the university is XYZ. University is equal to XYZ. Now let us display the data here. So print off. So how to print off? How to access the static variable? By using the class name. So student dot, and what is the static variable? XYZ. So print off student dot XYZ. Now what will happen? Whenever we call the display method, then university XYZ will be printed, and whenever we call s2 dot display method, then also university XYZ will get printed. So here also there is some mistake. So object has no attribute XYZ. Object has no attribute XYZ. So student dot, I'm sorry. Here what is the name of the static variable? UNIV. So run the program. So 72 Ramesh XYZ. So static variable is common for all the objects. 73 Mahesh XYZ. If we want, we can change that content inside the constructor also. So student dot UNIV is equal to, let us change to some ABC. Now what will happen? Initially static variable contains XYZ, and whenever this object is created, then the constructor will get executed. So university will be changed to now ABC. Now if we display university, then ABC will get displayed. In place of XYZ, now ABC will get printed. So now in place of XYZ, ABC got printed. So this is about static variable. Now let us see about the static method. So we have to use the decorator @static method. So def, let name of the static method is show. So def show off. Static method doesn't accept self as the parameter. What is the use of static method? It is mainly useful in order to access the static variable. By using static method, we can't access the instance variable. Okay. So student dot, now let us change the value. So student dot university is equal to, let us change the university to some JNTU. Now let us display that value. So print off student dot UNIV. So this is about static method. Static method means we have to use @static method decorator. It should not contain self. Now we have to call the static method. Static method can be called using what? Class name dot. What is the object name? Student dot. What is the object name? Show is the object. So student dot show. Control. Now let us run the program. So whenever we call the show method, then what will happen is we will get output as JNTU. So first what will happen? First 72 Ramesh, and after that ABC will be printed. 73 Mahesh, ABC will be printed. But in static method, we will get the message as JNTU. So we got the output as 72 Ramesh ABC, 73 Mahesh ABC, JNTU, some JUNTU. So there is no problem. So this is about static method. Here in place of class name, we can use object also. There is no problem. Why? Because here we have only one class. Whereas if we have multiple classes, If we want to make use of this class data in some other class data, then we must use the class name. But here we have only one class, so we can use the object also. So s1 dot object. Let us change the content so that you know whether that method was successfully called or not. We change it to JNTU. JNTU. If you see here, we got output as JNTU. Here we have only one class, so that's why we can use the object. There is no problem. If we have multiple classes, then if we want to use that static variable in another class, then we must use that class name. Okay. Now let us see the class method. Class method is also useful in order to access the class level variable. Here we have to use the decorator @class method. Let us define the method def. Let name of the class method is C method. C method. Here we must pass a class level object. Let that object is CLS. Instead of CLS, you can pass any value. There is no problem. Now, in order to access that class level variable, that is static variable, we must use that class level object. So CLS dot university is equal to, let name of the university is Oxford. Oxford. Now let us print the data. So print of CLS dot university. University. Now let us call the method. So we can also call the class method by using the class name. So what is the name of the class? Student dot what is the name of the method? C method. Student dot C method. Student dot C method. Now let us run the program. Let us run the program. So we got output as Oxford. So this is about static method and class method. And what is a local variable? This roll number and name is nothing but local variable. This data is nothing but local variable. If you want, you can name a variable like this. A is equal to 100. So this is local variable. Print of A. Print of A. Now 100 will get printed. Whenever we call the display function, then in addition to the data, 100 also will get printed. So let us see the output. So here we got 100. We can access the local variable directly. There is no need of any object. There is no need of self. So this is about different types of variables and different types of methods in Python programming. In this video, we are going to discuss about the abstract class and the abstract method in Python programming. First, let's see what is abstract class. What is abstract class? Abstract class. The abstract class is a collection of abstract methods. So it is a collection of abstract methods. Collection of abstract methods. Next, what is abstract method? What is abstract method? The abstract method contains only declaration part. Abstract method has only declaration. That is, it doesn't have any definition. So an abstract method doesn't contain any definition. It should contain only declaration. It should contain only declaration. It doesn't have any definition. So let us see some more points. An abstract class should not be instantiated. The abstract class should not be instantiated. We know what is instantiation. It should not be instantiated. Instantiation means the process of creating an object. So it is not possible to create an object for the abstract class. If we try to create an object for the abstract class, then an error message will be generated. Okay. So this is about what is abstract class. So when abstract class is mainly implemented, if there is inheritance, then only we can implement the abstract classes. If there is no inheritance, then it is not possible to implement the abstract class. So inheritance is compulsory in order to implement the abstract class. Here in Python programming, the abstract class is a subclass which extends from abstract base class. Here we have a module called ABC. So from ABC, here ABC is a module. From ABC module, we have to import abstract base class. Here ABC stands for abstract base class. This abstract base class is available in ABC module, as well as we have to import abstract method. Abstract method. Here what is ABC? ABC is a module. We know what is a module. Module is a collection of classes and methods. So if we want to implement abstract base classes, if we want to implement abstract class, then we have to create that abstract class by extending from the abstract base class. So here ABC is an abstract base class. This is available in ABC module. Abstract method is also available in ABC module. Okay. Now let us see an example. Parallelly, we will discuss the theory also. So let us create a class. Let name of the class is abstract demo 1. Let name of the class is abstract demo 1. Let A is uppercase letter. Let here also D is uppercase letter. Abstract demo 1. So this is the abstract class. So this parent abstract class must extend from ABC. We know how to implement inheritance. If we want to implement inheritance, then we have to pass that parent class name as the argument. Here what is the parent class name? ABC. So we have to pass this as the argument. Colon. So this ABC stands for abstract base class. Here our child class name is abstract demo 1, which is inheriting from ABC. So this class will become now abstract class. Abstract class. Okay. Now what is abstract class? Abstract class is a collection of abstract methods. So first let us define one method. Here if we want to make a method as the abstract method, then we have to use the decorator called @abstract method decorator. So we must use this decorator on top of the method. We must write this decorator on top of the method definition. So then only that method will become the abstract method. Okay. So let us use the decorator @abstract method. So the following method will become what? Abstract method. @abstract method. Now let us define the method. DEF. Let name of the method is display. We know that we must pass one argument, that is self as the argument. Okay. Self as the argument. Here this is abstract method. What is abstract method? Abstract method contains only declaration. It doesn't have the definition. So we have to pass either pass or none. Here the body of the abstract method is either pass. Pass specifies that this method doesn't perform any operation. Nothing will be performed. So when this abstract method is required, if in child classes, the corresponding child classes can provide their own definitions for the abstract method. So in the type of occasion only we have to use the abstract method. So abstract method means if we define a method in a class, that class will become the abstract class. So abstract class contains some methods. So who will provide the definition for the abstract methods? The child classes which are inheriting from the abstract class has to provide the definition for the abstract methods. We can create an object for the abstract class, but we can't create an object for the, we can create an object for the child class, but we can't create an object for the abstract class. So for this class, for abstract demo 1 class, it is not possible to create the object. Okay. Now the child classes has to provide the definition for the abstract methods. Okay. Now let us define a child class. So class, let the next class name is abstract demo 2. Abstract demo 2. Here this is a child class of this class abstract demo 1. Abstract demo 1. Abstract demo 1. So abstract demo 2 class is a child class of abstract demo 1. Now this child class has to implement, has to override the methods which are present in abstract demo 1 class. Abstract demo 1 class contains one abstract method. So it has to provide that method definition. So def display of self, def display of self, it can provide that method definition. So print of, so this is nothing but abstract demo 2 display method. Let this is the body. Okay, next we have to create object for the class. Here abstract demo 1 is abstract class. It is not possible to create object for this class, but we can create object for this class. Okay, this is not abstract class. So object is equal to abstract demo 2. Now with the help of the object, call the display method. Okay, so whenever display method is called, then the control goes to the display method and this body will get executed. So abstract demo 2 display method, so that body will be executed. So this is about what is abstract class and what is abstract method. So here, who will provide the definition for the abstract method? The child classes which are implementing the abstract class has to provide the definition for the methods which are present in the abstract class. Suppose abstract class contains 2 abstract methods. Then for those 2 methods, the child classes has to provide the definition. Let us see that in the execution. Now let us see the execution. Now let us see the program execution. Here I am opening new file in IDLE. So the first statement is from ABC. This ABC is a module. From this module, we are importing a class called ABC. Here ABC stands for abstract base class, and we have to import a method called abstract method. Okay. Now let us define an abstract class. So class, let name of the class is abstract demo 1. This is an abstract class, so it has to be inherited from ABC, abstract base class. So this is abstract class. So in comments I am writing as abstract class. We know that comments are not compiled and not executed. Now let us have a method in the abstract class. If we want to define an abstract method, then we must use the decorator @abstract method. So this is decorator. So let us define the abstract method. So def, let name of the method is display. So on top of this display, we have written the decorator abstract method. So automatically display will becomes abstract method. Here display method is present in abstract demo 1 class. So abstract demo 1 class will become the abstract class. Here we know that abstract method contains only declaration. It doesn't have any body. So that's why here we are using pass. So pass specifies that nothing will be performed. No operation will be performed. So abstract method means we should not perform any operation. The child classes has to provide the definition for the corresponding methods. Okay. Now let us have the child class. So class. So this class is abstract. Let name of the class is abstract demo 2. And here this class is inheriting from abstract demo 1 class. Abstract demo 1 class. So we must pass abstract demo 1 as the argument. So what we have to do now? We have to provide the definition for all the methods which are present in abstract demo 1 class. Here abstract demo 1 class contains only one abstract method. So for that method, let us have the definition. So def display of self. Now let us provide the definition. So print of, so this is nothing but abstract demo 2 display method. Okay. So body is over. Next, come out from the classes and let us create the object. Is it possible to create an object for the abstract demo1 class? Let us have an object obj is equal to abstract demo1. Now let us see whether it is working properly or not. Let us save the program. Let name of the program is ABS. Okay. So let us run the program. F5. So we got an error. What is that error? Can't instantiate abstract class with the abstract method display. Here the abstract class contains one abstract method. Okay. So it is not possible to create the object. Okay. Why? Because abstract method means that method doesn't contains any definition. So if the method contains the definition, then we can create the object, but it doesn't contain any definition. So it is not possible to create an object for the abstract class. So let us have object for the second class, that is demo2. Demo2 is not an abstract class. This class is called as concrete class. Concrete class. So concrete class means that class contains all the definitions. Concrete class. It doesn't contain any abstract method. Concrete class means it contains normal methods. Those methods can also be called as concrete methods also. Concrete methods means that method contains the definition. If concrete methods are present in the class, then that class is called as the concrete class. So concrete class contains the concrete methods. Concrete methods contains the full functionality. So obj dot display. Now save the program, run it, F5. So we got the output as abstract demo2 display. Now let us have one more method, one more abstract method. Let us use the decorator @ abstract method. Let us define one more method, one more abstract method, def. Let name of the method is show. So self, this is also abstract method. So we must we must write pass. So pass means it doesn't contain anything. It doesn't perform any operation. Nothing will be performed. Okay. Now let us see whether the program will work properly or not. Let us run it. So here also we got an error. Can't instantiate abstract class abstract demo2 with abstract method show. Here what is abstract demo2? Abstract demo2 is a child class which is inheriting from abstract demo1 class. But abstract demo1 class is abstract class. So abstract class, this abstract class contains two abstract methods. So abstract demo2 has to provide the definition for those two methods. But here it is not providing the definition. We know that it is not possible to create an object for the abstract demo2 class. Okay. Now what we are doing is, let us have one more class. Let us have one more class. Let name of the class is abstract demo3. Abstract demo3. Let abstract demo3 is also extending from abstract demo1 class. Why? Because here abstract demo1 class is what? Abstract class. Now let us define the two methods. Okay. In abstract demo2. So let us copy the code. Control C. Let us paste in abstract demo3. Control V. So what is the body of this method? Abstract demo3 display. Now let us define the second method also. What is the second method of abstract demo1? Show. Let us provide the definition for show method also. So print of abstract demo3. So this is which method? Show method. Show method. Okay. Show method. Now here if we observe abstract demo1 class, abstract demo1 class is abstract class. Why? Because it contains two abstract methods. Whereas what about abstract demo2? Here abstract demo2 is also abstract class. Why? Because in abstract demo2 we have not provided the definition for the show method. But here what is the point? Whenever a child class is implementing the parent class, whenever a child class is inheriting the abstract class, then the child class has to implement or override the abstract methods of the abstract class. Here abstract demo 2 is a child class of abstract demo 1. Abstract demo 1 is a abstract class. Now abstract demo 2 has to provide the definition for both the methods. But in this class, we have provided the definition for only display method. So now this class will become abstract class. So we know that it is not possible to create an object for the abstract class. Now we can't create object for abstract demo 2. What about abstract demo 3? Is it abstract class or concrete class? It is a concrete class. Why? Because what is a concrete class? It contains all the methods definition. Here abstract demo 3 is a child class which is inheriting from the abstract class abstract demo 1. Abstract demo 1 contains two abstract methods and both the methods definition is available here. So that's why we can say that this is concrete class. Now we have to create object for which class? Abstract demo 2 or abstract demo 3? Abstract demo 3. Why? Because in abstract demo 2 the show method definition is there. So it is abstract, the show method definition is not there. So that is abstract class. So now let us create an object for the third class and call the show method also. Call the show method also. Now let us save the program and run it. Now we got the output as abstract demo 3 display method, abstract demo 3 show method. So this is about abstract class and abstract method in Python programming. In this video, we are going to discuss about polymorphism in Python programming. Polymorphism is derived from two Greek words. They are poly and morphism. Poly means many, whereas morphism means forms. So the definition for the polymorphism is representing one thing in many forms. Representing one thing in many forms is called as polymorphism. In Python programming, we can implement polymorphism mainly in three ways. The first way is operator overloading. Operator overloading. Second way is method overloading. Method overloading. And third way is method overriding. Method overriding. So by using these three approaches, we can implement polymorphism. Let us discuss all the three approaches one by one. Okay. So what is the first approach? The first approach is operator overloading. Operator overloading. Operator overloading means using the same operator for different purposes. Using the same operator for different purposes. For different purposes. That is, we can provide extra meaning. We can provide extra meaning to the existing operator. We can provide extra meaning to the existing operator without changing its previous meaning. Without changing its previous meaning. So this is the definition. So operator overloading means we can provide extra functionality to the existing operator without changing its previous meaning. Let us take the example of plus. By using plus, we can add two numbers. What is the result of 10 plus 20? 30. Likewise, by using plus, we can concatenate two strings. We can join two strings. Let the first string is Ram, whereas the second string is Babu. If we concatenate Ram and Babu, then we will get Ram Babu. So by using plus operator, we can add two numbers as well as we can concatenate two strings. Is it possible to add two objects? It is not possible. We can't perform addition operation on two objects, but we can make that as possible by using operator overloading. So by using operator overloading concept with the help of plus operator, we can perform addition operation on two objects. Now let us take an example program for that. Let us take an example program for the operator overloading. So let us define the class. Let name of the class is number. Let n is uppercase letter. Let us define a constructor def underscore init underscore. The first parameter of init method is self. There are three members are there, ABC. Let we have three members. Now let us do the initialization. So self dot A is equal to A, self dot B is equal to B. So next one, self dot C is equal to C. Now let us create an object. So here I am creating the object. So obj, let the first object name is N1. N1 is equal to, what is the name of the class? Number. So N1 is equal to number of, let the parameters are 1, 2, 3. 1, 2, 3. So whenever the statement is executed, here we have a constructor. So the control goes to the constructor. So in N1 object, the value of A is 1, the value of B is 2, the value of C is 3. Okay. Likewise, let us create one more object. N2 is equal to number of, let the parameters are 4, 5, 6. So whenever the statement is executed, then the corresponding constructor is going to be executed. So what are N2 values now? ABC. So what are the values now? 4, 5, 6. In N2 object, A value is 4, B value is 5, C value is 6. Let the next statement is N1 plus N2. N1 plus N2. So N1 plus N2 means we have to perform addition operation on these two objects. So we have to get the result as, so what is the result of, what is the sum of these two objects? 1 plus 4 means 5. So we have to add these two numbers. So we have to produce output as 5, 7 and 9. But whenever the statement is executed, then Python interpreter will produce an error message. Why? Because it is not possible to perform addition on two objects. So now we have to overload the plus operator. Okay. So for that purpose, we have several functions are there. In order to overload the plus, we have a function called add function. So let us define that function or method. So def underscore add underscore. Here this add method mainly accepts two parameters. The first parameter is self, the second parameter is other. This is the predefined syntax. If we want in place of other, we can use some other statement also. So here N1 plus N2, whenever the statement is executed, then this add function will be called, add method will be called. Likewise, if we want to overload minus, then we have to use sub function. If we want to overload multiplication, then we have to use mul function. For all the methods, the prototype is same only, self comma other. In place of other, we can use some other name also, there is no problem. But in this example, which operator we are overloading? We are overloading the plus operator. That means for plus, we are providing extra meaning. What is that extra meaning? Addition of two objects. Okay. So whenever this statement is executed, then the control goes to the add method. And what is the left hand side object? N1. The content of N1 will be passed to the self, and what is the right hand side object? N2. The content of N2 will be passed to the other. Okay. Now let us perform the addition operation. A is equal to self dot A plus, so here N1 means self, whereas N2 means other. We have to add self dot A and other dot A. So self dot A plus other dot A. Now A contains 1 plus 4. What is the result? 5. Now A contains 5. Likewise, let us add B also. B is equal to self dot B plus other dot B. So self dot B means 2, other dot B means 5. So 2 plus 5 means 7. Next to C is equal to self dot C plus other dot C. Okay. Self dot C plus other dot C. So now result is calculated. Now we have to return the corresponding object to this function, this statement. So for that purpose, let us use an object called res. Res is nothing but an object. Here what is the name of the class? We know how to create the object. Object is equal to class name of, what are the parameters here? ABC. ABC. So whenever the statement is executed, then the corresponding result will be returned to this statement. Now here in the left hand side, let us use N3. So what is number of A comma B comma C? This addition 5 comma 7 comma 9. So now that result is available in RES. So in RES we have ABC and ABC values are that result. So whenever the statement is executed, now so the corresponding result is stored in this variable. So now RES will be returned. So for returning the RES, let us use a statement called return RES. So whenever the statement is executed, then RES value will be written and it will be assigned to N3. Now the result is available in N3. Now let us display the result. So print of N3 dot A comma N3 dot B comma N3 dot C. So now that result will be displayed. So what is the result? 5 space 7 space 9. That statement will be printed. Here if we want, in place of N3 is equal to N1 plus N2, we can write a statement like this. N3 is equal to, here what is the name of the class? Number is the name of the class. So number dot, which method we have to call? Underscore add underscore. What is the first parameter we have to pass? N1 comma N2. So like this also we can write. In place of this statement N3 is equal to N1 plus N2, we can write this statement also. Why? Because here actually we execute this statement 10 plus 20. Here what is 10 and 20? 10 and 20 are nothing but integer variables. So the class is int. So we can write this statement as int dot. So which function will be called? Plus means whenever the statement is executed, automatically add function will get executed. So underscore add underscore. What is the first parameter? 10 comma what is the second parameter? 20. Likewise, if you want to add two strings, then str dot. Why? Because the function for the str is the class for the corresponding strings is str underscore within the quotations Ram comma within the quotations Babu. Okay. So whenever this statement is executed, whenever this plus statement is executed, automatically add function will get executed, or we can call add function like this. In this way we can overload plus operator. Like this we can overload minus operator, star operator, division operator also. So minus means in place of add we have to use sub function, whereas mul means in place of add, star means in place of this add we have to use the mul function. Now let us see how we can overload the comparison operators. We have various comparison operators such as less than, greater than, less than or equal to, greater than or equal to, not equal to. Very, very simple. Less than means we have to use LT, greater than means we have to use GT, less than or equal to means LE, greater than or equal to means GE, equals to means EQ, not equals to means equals to, not equal to. Not equal to means we can use NE. Now let us see the function for how to overload the comparison operators. Let us overload comparison operators. Whether object 1 content is less than object 3 content or not. Here what is object 1 content? 1, 2, 3. So 1, 2, 3 means 1 plus 2 plus 3, 6. Whereas what is object 2 content? 4 plus 5 plus 6. So 9 plus 6, 15. So here we can say that object 1 is less than object 2. So it has to return true value. Now let us see how we can write that. So for that purpose, here we have to call the statement print of obj1 less than, here what is the object? I am sorry, here we have n1 and n2. So print of n1 less than n2. So whenever this statement is executed less than, then automatically the cursor will goes to the, for less than which function we have to define? LT function. So automatically control goes to the LT function. Actually we have to define that function here, but for space constraints I am writing here. Okay. So what is the function? Def underscore underscore LT underscore underscore. It has two parameters, self comma other, self comma other. Now let us add the first object. Okay. So A is equal to, or you can use some other name also, there is no problem. In place of A we can use O1 or B, C, it is our choice. We can use any other name. Let us add the first object. So A is equal to self dot A plus self dot B plus self dot C. Next B is equal to second object information is available in other. Why? Because whenever the statement is executed, n1 information will be passed to self, n2 information will be passed to the other. So B is equal to other dot A plus other dot B plus other dot C. Okay. Next, let us execute the statement. If A is less than B, then return true value, return true, else return false value. Here what is the first object? Sum 6. What is the second object? Sum 15. So 6 is less than 15. Condition is true. So true will be returned. Okay. And that result will be printed here. Okay. So likewise we can overload any operator. It may be less than or greater than or less than or equal to or greater than or equal to. So this is about operator overloading. Now let us see the remaining also. So after discussing method overloading and method overriding, we will see practically. So first let us see the theory and then we will execute the programs practically. Now let us see about the second polymorphism technique, that is method overloading. Method overloading means defining multiple methods with the same name but with different signatures. So we have to define same method. We have to define method with the same name but with different signatures. Here display of, here it has no argument. Display of A, it has one argument. Display of A comma B, it has two arguments. Display of A comma B comma C. So defining multiple methods with the same name but with different signature. So what is signature? Signature means number of arguments and order of arguments. Here number of arguments are only 0. Here number of arguments are 1. Here number of arguments are 2. Here the number of arguments are 3. And what is the order of the arguments? Order is also important. Here let A is integer. Then display of, let some other variable is A. Let this D is also integer. Now we can't overload these two methods. Okay. Why? Because this method is also having one argument which is of integer. This method is also having one argument which is of integer. But in place of D, we can have some other argument. In place of D, let us use string. Then we can overload these two methods. There is no problem. But here the problem is Python programming doesn't support method overloading. Whereas Java, C++, C#, all object-oriented programming languages supports method overloading except Python. Python can't support the method overloading. In order to implement method overloading, we have to use default argument concepts. So if we want to have method overloading, then we must implement what? We must use default arguments. Here method overloading means there is no need of inheritance. Only single class is enough. Okay. Now let us implement method overloading with the help of the default arguments. Class. Let name of the class is method overloading. Let name of the class is method overloading. Method overloading. Now let us have the method. DEF. Let name of the method is display. So DEF display of. We know that the first argument is self. What is default arguments? Already we discussed about default arguments in functions concept in Python programming. Default arguments means we can provide default value for each and every argument in function definition. So whenever we call the function with less number of arguments, then those default values will be taken. Let here the display function has 3 arguments. Okay, so for the 3 arguments we can provide the default values. So if we call the function with less number of arguments, then those default values will be considered. Suppose if you call the function with sufficient arguments, then these values will be taken. Default values won't be taken. So when default values will be taken, whenever we call the method, whenever a method is called with less number of arguments, then only default values will be taken. So let here we have 3 variables, a comma, b comma, c. Okay. Here default values will always be given from right to left. So from right to left we have to assign the default values. Let the value is none. Let the default value for C is none, for B is also none, for A is also none. Okay. So this is nothing but colon function starting block. So now let us print ABC values. So print A comma B comma C. Okay. Print A comma B comma C. Now let us create an object. Obj is equal to method overloading. Obj is equal to method overloading. So let us call the function with 0 arguments, obj.display. Here this function is not having any arguments. So whenever this statement is executed, control goes to the display function. But in this function we don't have any argument. So the default values will be considered. So what is a value now? None. So we will get output as, what is a value? None. B is also none. C is also none. Why? Because we call the function with less number of arguments. So in that occasion, default values will be considered. Now let us call the function with a single argument. Obj.display of, let the argument is 10. So now what will happen is, this 10 will be passed to A. Now A contains 20, whereas B and C will become none only. So what is the output now? A value is 20, B value is none. I'm sorry. A value is 10, B value is 20, C value is none. Now let us call the function with 2 arguments. So 10 comma 20, 10 comma 20. Now this 10 will be passed to A, 20 will be passed to B. So now A value is 10, B value is 20, C value is none. Okay. Now let us call the function with 3 arguments, 10 comma 20 comma 30. Now 10 will be passed to A, 20 will be passed to B, 30 will be passed to C. Now the output is 10, 20, 30. So this is about method overloading. So what is the problem here? Python programming doesn't support method overloading. So if we want to implement method overloading, then we must use the concept of default arguments. So this is about method overloading. Now let us see the last concept of polymorphism, that is method overriding. Method overriding. So method overloading means using the same method for different purposes. That is overloading. Using the same operator for different purposes. Using the same method for different purposes. So with the help of the same method, we are displaying 0 argument, 1 argument, 2 argument, 3 arguments. So method overriding. Method overriding is implemented only while using the inheritance. If there is no inheritance, then there is no method overriding. Okay. We know inheritance. Inheritance means we will have base class and derived class. Here we have a base class. Let base class contains a method called display method. So void display of self. Let us print some definition. So print of. So this method is nothing but base class display method. Base class display method. Now we need to implement the inheritance. Why? Because we have to implement what? Method overriding. So let us have the derived class. So class derived of. So here the derived class is derived from the base class. But let us assume that derived class is not satisfied with base class method definition. then derived class can redefines the method. Derived class can provide its own implementation for the method. So here what is the problem? So whenever we uses inheritance, we can use all the members of the base class in derived class also. So now derived class can also use display method. But here what is the problem? Derived class is not satisfied with base class method definition. In that occasion, derived class can redefine the method. Derived class can provide its own implementation for the method. So here what the derived class is doing is, derived class is redefining the base class method. Let the definition for the display method here is print of derived class display. Derived class display method. Display method. Now let us create an object. So here we know that in inheritance, we mainly create object for the derived class. So object is equal to, what is the name of the derived class? Derived. Now let us call the display method. So whenever we call the display method, then what will happen is, display method is available in both derived class and base class. Okay. So whenever we call the display method, then the derived class display method will overrides base class display method. That means the derived class display method is going to be executed, and this process is called as method overriding. We can implement method overriding only when base class and derived class contains, here not void, it is DEF. It is DEF. We can implement method overriding only when base class and derived class contains same method name as well as same prototype. Here we have only one argument, that is self. Here also we have only one argument. Okay. So whenever we call the display method, then derived class display method will overrides base class display method. So derived class display method is going to be executed. So we will get output as derived class display method. And this process is called as what? Method overriding. Why? Because derived class method is overriding the base class method. Now let us see the practical implementation. Now let us see the implementation. So new file. So first let us see the program of operator overloading. So class, name of the class is number. Now let us have the constructor. So def underscore underscore init underscore underscore. So self of. So totally 3 parameters, a comma b comma c. Now let us do the initialization. Self dot a is equal to a. Self dot b is equal to b. Self dot c is equal to c. Okay. Now let us create an object. N1 is equal to number of 1 comma 2 comma 3. Next N2 is equal to number of 4 comma 5 comma 6. Okay. Now let us use the statement N1 plus N2. So let us check whether this statement will work or not. Can we add 2 objects with the help of plus or not? So let us see that program. The program name is OPER. Let us run the program. So here we got an error message. What is that error message? Unsupported operand type for plus, number and number. So we can't perform plus operation on 2 objects. So if we want to perform, then we have to define, we have to overload the operator by using with add function. So underscore add underscore underscore. So the first parameter is self, second parameter is other. In place of other, we can use some other name also. There is no problem. Now let us add the objects. A is equal to self dot a plus other dot a. B is equal to self dot b plus other dot b. C is equal to self dot c plus other dot c. Now the result is available in ABC. Let us create an object. Let name of the object is res. Res is equal to, we know how to create the object. Class name of, we need to pass ABC. Now let us pass the information by using the return statement. So whenever the statement is executed, now that res value will be returned to the statement. Let us store the result in N3 object. Now N3 object contains that result. So now let us display the result. So print of n3 dot a comma n3 dot b comma n3 dot c. Control S. Let us run the program. So we got the output as 579. Why? Because that is nothing but addition of the two objects. 579. Okay. 1 plus 4 means 5. 2 plus 5 means 7. 3 plus 6 means 9. Or in place of n1 plus n2, we can write it as class name dot number dot. What is the function name? Underscore underscore add underscore underscore. Which objects we have to pass? n1 comma n2. Let us save the program and run it. So like this also we can call the function. Okay. Now let us overload one more operator, that is comparison operator. So print of, so directly print the result here, n1 less than n2, n1 less than n2. Okay. So whenever this less than statement is executed, then control goes to the less than function. So let us have a less than function or less than method. So self of same prototype. So self of other. Now let us add the first object. Let us add the first object with O1. So O1 is equal to first object means self dot A plus self dot B plus self dot C. Now O1 contains 1 plus 2 plus 3, that is 6. Now let us add the second object. So O2 is equal to other dot A plus other dot B plus other dot C. Now O2 contains second object sum. So 4 plus 5 plus 6 means 15. Now let us check the condition. If O1 is less than O2, then return true. Else return false. Here O1 is less than O2, so we will get output as true. So in this way we can overload comparison operators. Like this we can overload any other operator. So we got the output as true. Okay, like here we know that we can perform addition on two numbers like this, 10 plus 20. What is the result? 30. Or we can write the statement as 10 and 20 are nothing but integers. So integer dot underscore underscore add underscore underscore. Why? Because whenever plus is executed, then automatically add method is going to be executed. So 100 comma 200. So what is the result of 100 comma 200? We got the result as 30. So likewise we can perform concatenation on two strings also. Okay. Let A is equal to directly also we can write Ram plus Babu. So what is the result of Ram plus Babu? Ram Babu. Here Ram and Babu are nothing but string class str dot underscore underscore add underscore underscore. Here string means we can use either single quotation or double quotation. It is your choice. So Ram comma Babu. So let us see the output Ram Babu. So in this way we can do the operator overloading. Now let us see the method overloading. Let us see the method overloading implementation. So class, let name of the class is method overloading. Method overloading. Let us have the method def. Let name of the method is display method. So def display of. So the first parameter is self. Next A is equal to none. A is equal to none. Next B is equal to none. Next C is equal to none. C is equal to none. Okay. Why? Because Python doesn't support method overloading. So we have to make use of the concept of default arguments. Okay. Let us display ABC values. So print of A comma B comma C. Okay. Now let us create an object. So obj is equal to method overloading. Obj is equal to method overloading. Now let us call the display method with 0 argument. Next 1 argument. Obj dot display of 10. Obj dot display of 10. Next 2 arguments. Obj dot display of 2 arguments. So 10 comma 20. Next last one 3 arguments. Obj dot display of 10 comma 20 comma 30. Let us save the program. Let name of the method is meth. Let us run it. F5. So we got the output as none, 3 nuns, 10 none, none, 20, 20, 10, 20 none, 10, 20, 30. If you don't use default arguments, then what will happen is compile Python interpreter will generate the error message. Why? Because Python doesn't support this concept. Okay. So this is about method overloading. Now let us see about the last program. The last program is very simple program, method overriding. So class base, let us define the display method. So def display of self. Let body of the method is print of base class display method. Now let us base class display method. Now let us create the derived class. So class of derived of base. Let derived class is not satisfied with base class method definition. So derived class can provide its own definition for the method. So Control V. Now in place of base, let us write derived. So derived class display method. Now let us create the object. We know that inheritance means generally we will create an object for derived class only. So obj is equal to derived. Now let us call the display method. So obj.display method. Then which display method will get executed? Derived class display method will get executed. So that means derived class method is overriding the base class method, and this is called as method overriding. So derived class display method is executed. So this is about polymorphism in Python programming. In this video, we are going to discuss about introduction to exception handling in Python. Mainly there are 3 types of errors are there. So we can classify errors into 3 types. They are, first one is syntax error. We can call syntax error as compile time error also. Second one is logical error, syntax error or compilation time error. Second one is logical error. Third one is exception. So first one is syntax error or compilation error. So they will occur due to the syntactic mistakes. Let us take a statement. So print of I. So whenever this statement is executed, then the message hi will be displayed. Instead of print, let us assume that we have written like this, print within the quotation hi. So whenever this statement is executed, then what will happen is this is nothing but some syntactic mistake. In place of print, we have uses print. So some compilation time error will be displayed. So we got this error because of syntax mistake. Okay. So this is called as syntax error or compilation time error. Second one is logical error. So logical error will occur due to the mistake in the logic. So let us assume that we have a statement like this. A is equal to 10, whereas B is equal to 20. Now our aim is we want to perform addition on 2 numbers. Okay. But instead of addition, we have performed the subtraction. So we will get result as minus 10. But actually our intention is we have to produce addition as the result. Okay. So this is called as logical error. So logical error occurs due to the logical mistake. Okay. Third one is exception. So in this video we are going to discuss about exception only. So what is exception and how to handle the exceptions. Exception means it is a runtime error. Exception is a runtime error which will occurs during program execution. So compilation or syntactic error will occur during the program compilation. whereas logical error will occur during the program execution. Exception means it is a runtime error which will occur during the program execution. Whenever an exception occurs, then the program will be abnormally terminated. The program will be abnormally terminated. Let we have a program which contains totally 50 statements. Let our program contains 50 statements. Let 10th statement of our program is like this. Print of 10 by 0. Let the statement is 10th statement of the program. So print of 10 by 0. So this instruction is called as division by 0. Division by 0. So whenever the statement is executed, then what will happen is the program will be abnormally terminated. So that means totally the program has 50 statements. So remaining statements are 40 statements. So remaining 40 statements are not executed. That is the problem with the exception. So if we want to maintain normal flow of the program, if we want to execute the remaining 40 statements also, then we have to handle the exceptions. So exceptions are mainly useful in order to maintain normal flow of the program. In order to execute all the statements of the program, then we need to handle the exceptions. Okay. Now let us see how to handle the exceptions. So here what is the problem? Whenever there is an exception, then the remaining statements in the program are not executed. Whenever exception statement is executed, then the program will be terminated. So remaining statements are not executed. So the program execution will be disturbed. If we want to maintain the normal flow of the program, if we want to execute the remaining statements also, we have to handle the exception. Now let us see how to handle the exceptions. We can handle exceptions mainly by using 4 keywords. The first keyword is try keyword. Second keyword is catch. Third one is not catch. Second one is except. Third one is else. Fourth one is finally. So we can handle the exceptions by using these 4 keywords. Try keyword, except keyword, else keyword and finally keyword. Here else and finally are optional. It is our choice. We can use or we can't use. According to our requirement, we can use else and finally. Whereas these 2 are compulsory. First let us see what is the advantage of the try. Try contains a list of statements that may generate an exception. What is try? It contains a list of statements. A list of statements that may generate an exception. That may generate an exception. That may generate an exception. Suppose if there is a possibility of executing a statement as exception, then we have to place that statement in the try block. Okay. So try block contains a list of statements that may generate an exception. We know that division by 0 instruction, division by 0 statement may cause an exception. So we have to place those sort of statements in the try block. So if there is a possibility of exception by executing that statement, then we need to place those statements in the try block. So whenever an exception is raised in the try block, then that exception will be thrown to the catch block, except block. Okay. So whenever there is an exception in the try block, then that exception will be thrown to the except block. So except block contains a list of statements. It also contains a list of statements that handle the exception. That handle the exception. In C++, Java, in C#, we use catch, whereas in Python programming, we use except. Except is just like catch block that we use in C++, Java, C#. So it contains a list of statements that handle the exception. So whenever an exception occurs in the try block, that exception will be thrown to the except block. So except block handle the exception. Now let us see what is the use of else block. If there is no exception, then what will happen is else block will get executed. So else block will get executed if there is no exception. If there is an exception, then except block will get executed. If there is no exception, then else block will get executed. So else block also contains a list of statements, and those statements are executed if there is no exception. And finally block always gets executed irrespective of exception. Always gets executed irrespective of exception or no exception. Okay. So finally block always gets executed if there is no exception or no exception. Now let us see an example program based on these four: try, except, else, and finally. Okay. Let us see the program. First let us read two numbers from the keyboard. So a is equal to int of input of, let us read two numbers, enter a value. Let us read the second number from the keyboard, b is equal to int of input of, enter b value. Enter b value. Here our target is we want to perform division operation. Okay. By executing that statement, there is a possibility that we may get the exception. Why? Because if we give denominator value as 0, then it is an exception statement. So we have to place that statement in the try block. Okay. Why? Because try block contains a list of statements that may generate an exception. Okay. So the syntax for the try is very, very simple. Try colon. Try colon. Okay. So what is the statement here? C is equal to A by B. C is equal to A by B. Next, simply display the C value. So print C. Now let us write except. Except. What is except? It contains a list of statements that handle the exception. Okay. Let us write the body here. Print exception raised. Exception raised. Okay. There is an exception in the try block. So that's why this statement, this block got executed. Next, else. Else, let us write the statement print when else executed, else block will get executed if there is no exception. So no exception. No exception. Now last one, finally. Finally block always gets executed if there is an exception or no exception. So let us display the message as print program ends. Now let us see the program execution. Enter a value, enter b value. Let a value is 10, b value is 2. So first try block will get executed. C is equal to a by b. So what is the result of 10 by 2? 5.0. Okay. Print of C. So we will get result as 5.0. Print of C means that value will be printed. Here there is no exception. Okay. So except block won't execute. So if there is no exception, then what will happen is the control will be transferred to the else block. Why? Because we know that this else block will get executed if there is no exception. So what is the body in else? No exception. So we will get output as no exception, as well as next statement is finally. Finally always gets executed. So program ends. So we will get this output. Okay. Now let us run the program one more time. Let a value is 10, b value is 0. Next try C is equal to 10 by 0. So 10 by 0 means exception. So whenever there is an exception, that exception will be thrown to the except block. That exception will be thrown to the except block. Now except block will get executed. What is the message here? What is the message here? Exception raised. Exception raised. So this statement will get executed. Next here, else block won't get executed. Why? Because else block will get executed if there is no exception. But here we have an exception. So else block won't get executed, and finally always gets executed. So we will get output as program ends. So we will get these two lines as the output, whereas here we will get these three lines as the output. So in this way we can handle the exceptions in Python programming. In the future videos we will discuss some more topics on the exception handling. Now let us see the program execution. Now let us see the program execution. Let us read two numbers from the keyboard. A is equal to int of input of enter a value. enter a value. Next b is equal to int of input of enter b value. Enter b value. Now within the try, place the statement c is equal to a by b. Now display the result, print of c. Next, except block, except. Let us display some message, print exception raised. So there is an exception in the try block, so that's why this statement has executed. Next, else block, print no exception, no exception. And the last one is finally print program ends. Now let us save the program. Let name of the program is ex. Let us run it. Let a value is 10, b value is 20. So we got result as 5.0. There is no exception, so that's why else block got executed, no exception, and finally block always gets executed, so program ends. Now let us run the program one more time. A value 10, let b value is 0. Now what will happen? 10 by 0 means it is an exception statement, so directly control goes to the except block. Okay, the result won't get printed. Okay, control goes to the except block. So what is the statement there? Exception raised. Next, else block won't gets executed, and finally block will gets executed. So exception raised, program ends. So in this way we can write the programs based on the exceptions. In this video we are going to discuss about built-in exceptions in Python programming. Built-in exceptions are nothing but predefined exceptions. So those exceptions were already defined. For here, exception is the base class. Exception is the base class. For all these built-in exceptions, we have 10 exceptions are there. First one is attribute error. Second one is assertion error. Third one is file not found error. Fourth one is index error. Fifth one is key error. Sixth one is module not found error. Seventh one is name error. Eighth one is type error. Ninth one is value error. 10th one is zero not found error. We know that exception means a runtime error which will occurs during the program execution. So whenever exception occurs, then the remaining statements in the program are not executed. The program will get abnormal termination. We will handle exceptions mainly by using two keywords. First one is try, second one is except. Try contains a list of statements that may cause an exception, whereas except contains a list of statements that handles the exception. Now let us see all these exceptions one by one. The first one is attribute error. So attribute is nothing but member of a class. Member of a class. Attribute error will be raised if an object is trying to access an attribute. Attribute is nothing but member of the class. An attribute which doesn't exist. Now let us see an example for this one. Example 1. Class. Let name of the class is a demo. Let it contains an attribute called a. Let a value is 10. Now let us create an object. Obj is equal to demo. Obj is equal to demo. Now let us display a value. So print of obj.a. So whenever this program is executed, then what will happen? What is a value? 10. So we will get 10 as the output. Let us write one more statement. So print of, within the double quotations, rest of the program. Rest of the program. So we will get output as 10, and in the next line rest of the program will get printed. Instead of A, let us assume that we accessed B. So print of obj.b. But here B is not an attribute of the class. Here only we have A. Now we will get the error message as, here the output is attribute error. Attribute error. So this is about what is attribute error. So when attribute error will be generated, if an object is trying to access an attribute which doesn't exist. So rest of the program, the remaining statements in the program are not going to be executed. Why? Because here whenever the statement is executed, then this attribute error exception will be generated. So the remaining statements are not going to be executed. So now we have to handle the exception with the help of try and catch. Now let us handle the exception. Here we got the error message because of the statement print of obj.b. So now we have to place obj.b in try block. Why? Because try block contains list of statements that generates an exception. So try print of obj.b. Here the statement got an exception. So whenever an exception is raised, then the control that exception will be thrown to the except block. Except colon. Here we can display some message except print of exception handled. Exception handled. Let the last statement of the program is print of rest of the program. So print of rest of the program. So now what is the output for this program? So first, class A is equal to 10, object is created. Try print of obj.b. Here object is trying to access an attribute which doesn't exist. So it throws an exception. So that exception will be thrown to the except block. So what is except block? Exception handled. So that message will be printed, and after that the rest of the program is going to be executed. Okay. So that is the output. Here instead of that we can write as, after the except we can write as attribute error. Why? Because we know the exception name, error name, attribute error. Print of, just we can display some message according to our choice. Attribute B doesn't exist. Attribute B doesn't exist. And the next statement is print of rest of the program. Rest of program. So whenever try block is executed, then it will throws an attribute error exception. So that will be thrown to the except block. So attribute error. So now this except block will get executed. Attribute B doesn't exist, and rest of the program. So we can handle the exception only by using except or by specifying the error after the except. Here if we want, we know that exception is the base class for all these exceptions. So all these exceptions are derived from this class. So we can write as except exception as E. If you don't know what is that exception that we need to handle, then we can write as exception as E. Then here E is nothing but some reference. So we can display that reference, print of E. Now what will happen is, here that exception message will be thrown to this E reference. Okay. So what is E now? Here E means demo object has no attribute B. Demo object has no attribute B. So that message will be printed, and after that rest of the program will get printed. So we can write except by using these three ways. So what is the first way? First way is just write except, and in the except block display some message. And the second way is except, after except display the corresponding exception class. Attribute error, assertion error, index error. Likewise we have several exceptions are there. And what is the third way? Except space exception space as space e. Okay, so print off, here we need to display this e. So we can handle the exception in these three ways. Okay, in the implementation we will discuss all these three ways. In the next examples we are going to see the first approach, except colon, because that is the simplest approach. And let us see the second type of error. The second type of exception is assertion error. So A and E are uppercase letters, remaining all are lowercase letters. Let us see the syntax for the assert statement. Assert space condition comma within the double quotations error message. Error message. So this is the syntax for assert. So first condition will be evaluated. If the condition is true, then the rest of the program will get executed. Whereas if the condition is false, then the program execution will be stopped and it returns assertion error with error message. So when it will returns the assertion error, whenever the condition is false, then the program execution will get stopped and it returns assertion error with the error message. So whenever the condition is false, then only it will returns the message. Now let us see an example for this. Example, A is equal to 1, B is equal to 0, B is equal to 0. Next, assert. What is the syntax? Some condition, we have to write some condition. Let the condition is B not equal to 0, comma, within the double quotations, some error message. Here the error message is something like this, invalid operation. Invalid operation. Let the next statement is print off rest of the code, rest of program, rest of program. And before that, if you want, we can display some message also. Yeah, rest of program. This is enough. Rest of program. Rest of program. So now what will happen? A is equal to 1, B is equal to 0. Print B not equal to 0. B not equal to 0. But what is B value? 0. 0 is not equal to 0. Condition is false. So whenever the condition is false, then what will happen? The program execution will get stopped and it will returns assertion error with this message. So we will get output as assertion error colon. What is the message we passed? Invalid operation. And the program will get abnormal termination. So remaining statements are not going to be executed. So now we have to handle the exception. So how to handle the exception? So A is equal to 1, B is equal to 0, try colon, assert B not equal to 0, assert B not equal to 0, comma, invalid operation, invalid operation. Next, except. So whenever an exception is generated, then that exception will be thrown to the except block. So here write the message. So print off exception handled, exception handled. Next, print off rest of the code, rest of program. So what is the output for this program? Assert B not equal to 0. But what is B value? 0. 0 not equal to 0. Condition is false. So what will happen? Whenever the condition is false, here the condition is false. So it will throws assertion error message. So now the control will goes to the except block, except. So this message will get printed, exception handled, and after that rest of the program will get displayed. Okay. Now let us see the next one, that is file not found error. File not found error. File not found error is raised if file is not available. Okay. If you are trying to perform an operation on an invalid file, a file which doesn't exist. So let us write the syntax. Let us open the file. fp is equal to open of. Let abc.txt is not there in the system, comma, mode of the file. Here we have to open the file in read mode. Why? Because if you open the file in write mode, then if no file exists with this name, then a new file will be created if you open the file in write mode. So that's why we have to open the file in read mode. Let us display some message. So print of fp.read, fp.read. Here we are trying to read the content of a non-existent file. So it will throws what? File not found error, file not found error, abc.txt, no such file or directory. Okay. Now we have to handle the exception. So how to handle the exception? So we need to place that statement fp.read in try block, and here we have to write except block. In accept block, we can write the message as exception handled and then rest of the program. Okay. So handling the exception is very, very simple in the same way as assertion attribute. And the next one is index error. Index error. Here this exception will be raised if we try to access an index which is out of the range. Which is out of the range. Let we have a list like this. So L is equal to, so this is our list. So within the square brackets 10, 20, 30. So now we can access only 3 elements. L of 0, L of 1, L of 2. But I am trying to access L of 3. Is it possible to access L of 3? No. So now it will generate what? Index error. Index error. Let the next line is rest of the code. So this message won't get printed. So whenever the statement is L of 3. So instead of L of 3, let us use L of 5. So L of 5 is not here. L of 3 is also not there. We can access only L of 0, L of 1, L of 2. Okay. So L of 5 is not there. So it will throws what? Index error. It will throws index error exception. Okay. And this message rest of the program won't get executed. So we have to handle the exception with the help of try and catch that we will see in implementation part. Now let us see the next one, that is key error. Key error. Key error means if we try to access a key which doesn't present in the directory, then key error exception will be generated. So key error exception is mainly generated while accessing a key which doesn't exist in the directory. Let us create a directory. So D is equal to within the curly braces. Let name is Mahesh. We know that directory means we have to use curly braces and they are separated by key and value. Mahesh is key. Let marks 90 is value. Next key value pair is Ramesh and value is 80. So print of if we give D of Mahesh, then we will get output as 90. But here instead of Mahesh Naresh, just we given Naresh. So print of D of Naresh. This key is not present in the directory. So it will throws key error exception. Now we have to handle that exception with the help of try and accept that we will see in the implementation part, just like the previous ones. And the next one is module not found error. Module not found error. Module not found error. If we try to import a module which doesn't exist, then module not found error exception will be thrown. Okay. Let here just we have written a statement like this. Import Sudhakar. So this module is not available. This module doesn't exist. So now Python interpreter will throw module not found error exception. So we have to handle the exception with the help of the try and accept, just like the previous one. And the next one is name error. Next one is name error. Name means identifier. So this exception will be raised if we try to access a name, if we try to access an identifier which doesn't exist. So let we have two identifiers. A is equal to 10, B is equal to 20. Next to print of A comma B comma C. But this C, this name doesn't exist. This name doesn't exist. But we are trying to access this name. So that's why Python interpreter will throws name error exception. So for that we have to handle the exception by using with try and accept. And the next one is type error. Next one is type error. So type error exception. Type error will be generated if we try to perform operations on unsupported data types. So the result of 2 plus 3 is 5. The result of Ram plus Babu is Ram Babu. But if we try to add a number and a string, that is not possible. So in the type of occasion, interpreter will throw type error message, type error exception. So print of 2 plus, let the statement is Ram, 2 plus Ram. It is not possible. It is not possible to perform addition on a number and a string. Okay. So that's why Python interpreter will throw type error exception. So we have to handle the exception now. Let us see that in the implementation part. And the next one is value error. Value error. So value error means if we try to perform mistypecasting on a particular data, on a particular value, then it will throws value error message. Okay, let here we have a statement called a is equal to hello. A is equal to hello. Now a contains a string. It is not possible to convert that string into a number, but I want to convert, just we have written a statement like this, int of a. So converting string to integer, a number, that is not possible. So in the type of occasion, Python interpreter will throws value error exception. And the last one is 0 not found error. 0 not found error. So this exception will be thrown while performing the division operation. If the denominator value, if the second argument is 0, division by 0, then it will throws that exception. Let the statement is like this: a is equal to 1, b is equal to 0, print of a comma b. Then the interpreter will throws 0 not found error. Okay. Now let us see the practical implementation. So first error is attribute error. So class demo, a is equal to 10. Let us create an object, obj is equal to demo. Next, let us print a value first, obj dot a. Let us save the program. Yeah, do you want to replace it? Yes. So let us run the program. So we got error, we got output as 10. Now instead of a, let us access b. So print of obj dot b. Let us display one more statement, rest of the program. Now let us save the program, Control S. Let us run it. So we got error as attribute error. We got exception as attribute error. Why? Because demo object has no attribute b. So the remaining statements are not going to be executed. So rest of the program, the statement is not executed. Now we have to handle the exception so that remaining statements will also get executed. We have to follow the indentation. So try. Next, accept. So let us display some message. Print exception handled. Now let us see the output. So what is the output now? We have an exception in the try block. So control goes to the accept. So exception handled will get printed, and after that rest of the program will get printed. Exception handled and rest of the program. If we observe the previous output, the rest of the program won't get printed. Why? Because whenever an exception is generated, then the program will get abnormal termination. So the remaining statements are not executed. Or instead of this, after accept, we can write as attribute error. We know the type of the exception, attribute error. Accept attribute error and some message. Let us run the program. So we got the output as exception handled, rest of the program. If we don't know the type of the exception that is thrown, then we have to use exception class. This exception is the base class. So exception as e. Now we can display that e, that reference. So print of e. So whenever an exception generated in the try, then that exception will be thrown to the accept. Now this message will get printed. Demo object has no attribute b. And then rest of the program will get executed. Okay. So likewise we can handle by using these three approaches: accept colon or accept, and after that name of the error, or we can use accept class. Okay. Now let us see the next one. So the next type of exception is assertion error. So for assertion error, let us write the program. A is equal to 1, b is equal to c. Let us write assert statement. Assert b not equal to 0. So comma. Let us display some message: invalid operation. Okay. And then write some statement, print off rest of the program. So here the condition is false, b not equal to 0. but B value is 0. So what will happen? The program will get abnormal termination. So it will returns assertion error with that message. So assertion error, invalid operation. Now we have to handle the exception. So because of assert statement, we got the exception. So let us place that statement in the try block. Now handle the exception. So except, so print off, except print off. Here we can display any message according to our choice. Exception handled. Now let us run the program. Now we got exception handled as well as rest of the program. So in this way we can handle the exception. Now let us see the next one, that is file not found exception. So FP is equal to, let us open the file in read mode, open off abc.txt is not exist in my system. Let us open the file in read mode, and let us display the message. So print off fp.read. So read the data from the file and display the content. But here the file doesn't exist, so it will throw file not found error, no such file or directory. Now how to handle the exception? Let us place this statement in try block, and except print off exception handled, and then the last statement is print off rest of the program. So let us copy these statements so that while handling the remaining exceptions, instead of typing we can paste there. So Control C. Now let us save the program. Control S. F5, no such file. Let us see here, we got an error. So print off fp is equal try print off fp.read. So except, Control S, let us save the program. Except print off exception handled, indentation is correct only. So print off rest of the program. Control S, let us run it. So we got error as no such file or directory. So here some mistake is there. So let us place this statement within the try only. So within the try block, let us place this statement. Control V, Control S, F5. So we got the exception message. So here we need to place the file pointer within the try block only. Now let us see the next one. So the next type of exception is index error. Let us create a list. So L is equal to 10, 20, 30. So print off L of 5. So L of 5 is not here. So it will throw index error. List index out of range. Now let us handle the exception. So we have to handle the exception by placing the body within the try and then catch except block. Control, except. So what is the message? Print off exception handled. Next one, print off rest of the code. So rest of the program. So now let us copy this code. Control C. Now let us save the program. Control S, F5. So we got the message exception handled, rest of the program. Next one is key error. So key error will be generated while accessing a key which doesn't exist. So D is equal to Ramesh. This is the key. Let Ramesh marks 90. Second one Mahesh. Let Mahesh marks 80. Yeah, we have to use curly braces, not square bracket. Insert we use just square bracket. So D is equal to within the curly braces. Next to print off D off within the double quotations Naresh. But Naresh key is not available in the directory, so it will throw that exception, key not found error exception, key error. So this exception is what? Key error. So now we have to handle the exception. So try block. Now let us write the except block, control V, control S, F5. So we got that exception messages, exception handled, rest of the program. Now let us see the next one. The next one is module not found error. So when we are trying to import a module which doesn't exist, then it will throw module not found error exception. Import Ajala. So this module doesn't exist. So it will throw module not found error exception. Module not found error. Why? Because there is no module with the name Achala. Now what we have to do? We have to place this statement within the try block. Why? Because of this statement we got the exception. Now let us write the catch block. Control V. Let us save the program. F5. Now we got the exception message. Exception handled, rest of the program. The next one is name error. So name error. So let A is equal to 10, B is equal to 20. Print A comma B comma C. So here C doesn't exist, but we are trying to access C. So name error, that exception will be thrown. Now we have to handle the exception by placing a exception generated statement in try block, and then exception handled statement in except and remaining statements. So we got the exception messages. Next one is name error is over. Next one is type error. So we will get type error while performing operations on unsupported data types. So 9 plus within the quotations high, but it is not possible to add a number and a string. So that's why we got the message type error. So likewise you can handle the exception. Next one is value error. So we will get value error while doing typecasting. A is equal to hello. Unsupported typecasting. It is not possible to convert that string into integer. So it will generate value error. And the last one is zero not found error. A is equal to 1, B is equal to 0. Print off A by B, division by 0. So control S. So here the exception name is 0 division error and the message is division by 0. So this is about built-in exceptions or predefined exceptions. In this video, we are going to discuss about how to handle multiple exceptions in Python programming. We know what is exception. Exception is a runtime error which will occur during program execution. Whenever an exception occurred, then the remaining statements are not going to be executed. That is, the program will get abnormal termination. Let the program contains 100 statements. Let 10th statement of the program is an exception. So division by 0. This is an exception statement. Let the 10th statement is an exception statement. So whenever an exception occurred at the 10th statement, then the remaining 90 statements are not executed. Remaining 90 statements are not executed. The program will get abnormal termination. So now our target is we have to handle this exception in such a way that the remaining 90 statements should also get executed. So that should be done mainly by using two keywords. The first keyword is try keyword. The second keyword is except keyword. So try contains a list of statements that may causes an exception. Suppose by executing a particular statement, there is a possibility that we may get an exception. So those type of statements should be placed in the try. Next, whenever an exception occurred in the try, then that exception will be thrown to the corresponding except block. So except block contains a list of statements that handles the exception. Simply we will display some messages regarding the exception in the except block. So that is about what is exception handling and what is try and catch. And now in this concept we are focusing on how to handle multiple exceptions in Python programming. So the name itself specifies the meaning. A try block can have multiple except block. A try block can have multiple except blocks. So likewise we can write n number of except blocks. So a single try can have multiple except blocks. So which except block will be executed? That depends upon the type of the exception that is thrown. Okay. Here we have different types of exceptions like zero division error exception, index error, next we have type error, value error, name error, attribute error, assertion error. We have different types of exceptions are there. Let the statement is like this: division by 0. So numerator is any value, whereas denominator is 0 value. So if this statement is executed in the try block, then what will happen is it causes zero division error exception. It causes zero division error exception. So whenever this statement is executed, then the control goes to the except block with zero division error class. Okay. Next we have let we have a list which contains three elements. So 10, 20, 30. So we can access only 3 elements now: L of 0, L of 1, L of 2. But we are trying to access L of 5. But it is not possible. Why? Because here the range means for 0, 1, 2 only. So when we are trying to access L of 5, then index error exception will be thrown. Index error exception will be thrown. So the control will goes to the except block with index error. The control goes to the except block with the class index error. Let we are trying to perform some unsupported operation. We know that we can perform addition operation on 2 numbers. The result of 2 plus 5 is 7. As well as we can concatenate 2 strings. Ram plus Babu. Here we have 2 strings. When we concatenate these 2 strings, we will get output as Ram Babu. But it is not possible to concatenate a number and a string. If we try to perform addition operation on a number and a string, then it will throw type error exception. So the control goes to the except block with type error class. Okay. And now let us see an example program for this. After that we will see the practical implementation. Let us handle these exceptions because these 3 are most commonly used exceptions. Let me have a try block. Let me have a variable a is equal to 10. Next b is equal to, let b value is 2. Next let me have a list. L is equal to 10, 20, 30. Let us display 2 statements. Print of a by b, a by b. Next to print of, let us access an element which is in the range L of 1, L of 1. Next let us throw the exceptions, except the first exception is zero division error. This is a class. We know the naming conventions for a class, predefined class. So the first letter of every word is uppercase letter. So Z, D, E are uppercase letters. Now let us display some message. It is your choice. We can display the message according to our choice. So print division by error. So we got this error. Why? Because the denominator value is 0. And next type of exception is index error. So index error. Index error, print index is beyond the range. So index is out of range. Out of range. Next here, if we want, we can write the default except. So this is called as default except block. So this except block can handle any type of exception. It may be zero division error or index error or attribute error or type error or value error, name error. This is called as default except block. Default except can handle all the exceptions. So for name sake, we are discussing this concept. So instead of all these except blocks, we can write the single except. So this single except can handle all the exceptions. Okay. But it should be the last except block. We should not place this except block as the first except block. So default except block should be placed as the last block, last except block. So print just display some message, exception occurred, exception occurred. Okay. Now let us see the last statement, print rest of the program. Print rest of the program. Rest of the program. Now let us see the program execution. A is equal to 10, B is equal to 20, L is equal to 10, 20, 30. So we can access L of 0, L of 1, L of 2. Next to print of A by B. So what is A value? 10, B value 2. So 10 by 2 means what? 5.0. We know that in Python division means it produces floating point number as the output. So we will get output as 5.0. Next to print of L of 1. So L of 1 means which element? 0 means 10, 1 means 20. So print of L of 1 means 20 will be printed. Here there is no exception in the try block. So the control will comes out from all the except blocks. Okay. So when the except block will get executed, if there is an exception occurred in the try, but there is no exception occurred in the try, so no except block will get executed. So control comes out from all the except blocks. So what is the last statement after the last except block? Rest of the program. So rest of the program. So this message will be printed. So this is the output. Now let us write some mistake. Instead of L of 1, let us access L of 5. Let us access L of 5. Now let us see what is the output. Print of A by B. So 10 by T. What is 10 by 2? 5.0. So there is no problem here. Print of L of 5. We are trying to access an element which is beyond the range. So which exception will be generated now? Index error. So the control goes to the except block which handles index error. So this is that except block which handles index error. So the control will goes to this except block. So we will get message as index out of range. Index out of range. Next the control comes out from this except block. Okay, this is executed. Out of all the except blocks, only one except block will get executed. Okay, so the control will comes out from the remaining except blocks. So what is the last statement? Rest of the program. Rest of the program. So this will be executed. Now let us do some modifications. Let B value be 0. Let B value be 0. We are trying to access L of 1 only. Okay. Now let us see what is the output. So print of A by B. So 10 by 0 means what? 10 by 0. 10 by 0 means it is an exception. So here an exception occurred. So whenever an exception occurred, then this statement won't get executed. Okay. Control goes to the except block. So this is which exception? This is 0 division error exception. This is 0 division error exception. So control goes to the except block which handles 0 division error. So what is the message here? Division by 0. So first here we will get 0 division by error. Division by error. So we will get division by error as the output. Okay. Division by error as the output. And after that control comes out from all the except blocks. Next, rest of the program. Rest of the program. So this message will be printed. So in this way we can handle multiple exceptions in the Python programming. Now let us see the practical implementation. Now let us see the program execution. So try block. Let A is equal to 10. B is equal to 2. Next, let us have a list. L is equal to 10, 20, 30. Next to print of A by B. Next to print of L of 1. L of 1. Now let us have except block which handles 0 division error. 0. So Z is uppercase letter, D is uppercase letter, whereas E is uppercase letter. 0 division error. Let us display some message. So print of, this is nothing but what? Division by error. Division by error. Division by error exception raised or occurred. Next, let us have an except block with index error. So I and E are uppercase letters. I and E are uppercase letters. Let us display some message. Print. Yeah, I'm sorry. print index is out of bound, out of range. Next we can write a single except block which can handle this is the default except. It can handle all the exceptions. So print of an exception occurred or raised. Now let us write one more statement. Print rest of the code or rest of the program. Now let us save the program. Let name of the program is exc. Let us run it. So 5.0 20 rest of the code. Here there is no exception. So that's why control comes out from all the except blocks. So here we got message as 5.0 L of 1 means 20 and rest of the code. Now let us see. Now let us do some modification. Instead of L of 1, let us access L of 5. Control S. Now what will happen? We got the message as here print of A of B. So there is no exception here. So 5.0 will be the output. L of 5 means here we are trying to access an element out of the range. So here index error exception will be raised. So control goes to the index error. So we will get message as index is out of the range. And then control comes out from except blocks, rest of the code. Let us observe the output one more time. So 5.0 index is out of the range, rest of the code. Okay. Now let us do one more modification. So let b value is 0. Let us assume that we are trying to access L of 2 only. Now what is the output? Print of A by B means here b value is 0. So 0 division error with exception will be raised. So control goes to this except block. Okay. So division by error exception raised. So this message will get printed, and after that control comes out from the except blocks. Rest of the code will get printed. So if you observe the output, so we got division by error exception raised. So we got this message and then rest of the code. Division by error exception raised and rest of the code. So division by error exception raised and rest of the code. Okay. Now let us do one more modification. So print of 8 plus high. Here we are trying to perform concatenation operation on a number and a string, but that is not possible. So type error exception will be thrown. But here we don't have except block with type error class. So now the control goes to this except block. This except block can handle any type of exception. So now we will get message as an exception raised and then rest of the code. Here instead of b is equal to 0, let us write b is equal to 2. So there is no exception from the first two statements. Print of a by b, print of l by l2. So there is no exception from those two statements. So we have an exception only from this statement. So what is the output now? There is no exception from print of a by b. So we got 5.0 as the output, and there is no exception from print of L of 2. So that's why we got 30 as the output. Next, there is an exception in print of 8 plus high. So that's why that exception is thrown to the except block. Why? Because we don't have an except block with type error. Okay. So that's why this exception is handled. An exception raised. This except block got executed. An exception raised. So instead of that, what we can do is, so let us have one more except block. Let us have one more except block with type error class, unsupported data type. Okay, print of print of, let us display some message, addition or concatenation on number and string is not possible, and string is not possible. Okay, control S. Now what will happen, that exception will be thrown to this type error except block. So this message will get printed, and after that control comes out from the except, so rest of the code will get printed. If you observe here 5.030, concatenation on number and string is not possible, rest of the code got printed. So in this way we can handle multiple exceptions in Python programming very easily. In this video we are going to discuss about how to raise an exception in Python programming. We know that try block contains a set of statements that may cause an exception. Whenever an exception occurred in the try block, then that exception will be thrown implicitly by the interpreter to the except block. So here we have try block. Let a value is 10, b value is 0. Next let we have a try block. So let the statement is like this, print of a comma b. Next except block contains some statements. So print of exception occurred. So here in the try block we have print of a comma b. What is a value? 10. What is b value? 0. So this is nothing but an exception statement. 0 division by error. So whenever an exception occurred in the try block, then that exception will be thrown through to the except block. So that is to be done implicitly by the Python interpreter. Here we are not throwing the exception. It is the responsibility of the Python interpreter to throw the exception to the except block. In this concept, we are discussing about rise keyword. The purpose of the rise keyword is, by using rise keyword, we can raise an exception. We can throw an exception from the try to the except block. So if we want, we can raise an exception, and that exception will be thrown explicitly to the except block by using the rise keyword. The syntax of the rise keyword is like this. Rise, we have to specify the exception class name. So which exception you need to throw. So the class name should be specified. Here we have to use the predefined exception classes, built-in exception classes. We know that all the classes are derived from the class exception. So exception is the base class for all the built-in exception classes. We have several built-in exception classes like 0 division by error, index error, attribute error, name error, type error, value error, assertion error. Likewise, several built-in exceptions are there. Here we need to specify one of the exception class. It may be the base class exception or any other built-in exception class name. Now let us see an example for this. So what is the purpose of the rise keyword? The name itself specifies the meaning. Rise keyword rises an exception. So whenever that is executed, then the control will be transferred to the corresponding except block. Let us see an example for this. Let a is equal to 10, b is equal to 0. Next here we have try block. So within the try block, let us check some condition. If b double is equal to 0, so if b double is equal to 0, then it is what? Division by error. So this program is demonstrating rise keyword. So whenever b is equal to 0, then with the help of the rise keyword, throw the exception. So the syntax is like this. A rise exception class name. Exception class name. So what is the exception class name? 0 division error. So here this class name should be predefined class name. It may be either exception or any other built-in exception class. So zero division error. Zero division error. So whenever this statement is, so what is the purpose of this statement? Rise keyword rises this exception. So this exception will be thrown to the except block with the class name zero division error. So let us have zero division error exception. So except zero division error. Zero division error. Let us display some message. So print off. So what is why this exception occurred? Divided by 0. Why? Because here the denominator is 0. So that's why we got this exception. So let us see the program execution. So try if b double is equal to 0. In this program b is 0 only. So this statement got executed. Rise zero division error. So rise keyword rises this exception. So now the control will be transferred to the except block with the class zero division error. So this is that class. This is that except block. Okay. So here what is the message? Divided by 0. So this message will be printed. So if we want here rise zero division error. So for space constraints, I am writing here rise. What is the name of the class? Zero division error. Within the curly braces, we can provide the message. So what is the message? Divided by 0. Divided by 0. Here when we are providing the message, then we have to specify as ye. As ye. So except zero division error. This is the class name as ye. So if b double is equal to 0, so b value is 0. So condition is true. So rise keyword rises the exception. So what is the name of the exception? Zero division error. And here what is the argument here? Divided by 0. Now the control will be transferred to the except block with the class name zero division error. And this message divided by 0, that message will be stored in E. Now we have to display E. Print E. Now we have to display E. So if you display E, then what will happen? This message will get printed. Divided by 0. So likewise also you can pass. Okay. If you don't know the exception class name, simply we can pass exception. Exception is the base class from which all the built-in classes are derived. So except, so what is the name of the class? Exception. Except exception as E. So rise exception. Now the control goes to the exception class. Now the control goes to the except block with the class name exception. So divide by 0. That message will be stored in E. So print of E means that message will be printed. Okay. So likewise you can write n number of programs. Okay. Or directly also we can rise the exception. Try. So rise. Let the message is index error. Rise index error. So let us have index block. Let us have except block. Except. So what is the class here? Index error. Index error. Let us display some message. Print of index is out of range. Index is out of range. So without checking the condition also you can rise the exception. So try block rise index error. So now the control goes to the except block with the class name index error. Okay. So what is the message here? Index is out of range. So this message will get printed. Or let us take an example. We are reading some mocks. So mocks is equal to, let us read some mocks. Mocks is equal to int of input of enter mocks. Here let the subject maximum mocks is 100. So we have to enter a number from 0 to 100. So if the number is either less than 0 or greater than 100, then we have to throw the exception. Whereas if the number is in between 0 to 100, then display the mocks. That is our target here. Okay. Here just we read some mocks. Next within the try block, let us have the condition. If mocks is less than 0 or greater than 100, then we have to raise the exception. If mocks is less than 0 or mocks is greater than 100, then raise the exception. So which exception we have to throw here? Directly throw the exception class. Okay. So rise predefined base class name. So rise exception. Okay. Next, if this condition is false, then display the mocks. So print of mocks. Print of mocks. Except exception as ye. Here we didn't pass any argument, so directly print the message. So except print of mocks should be between 0 to 100. Mocks should be between 0 to 100. So let us see the program execution. Mocks is equal to int of input of, let the mocks is 90. So if mocks less than 0, so 90 less than 0, false. 90 greater than 100, false. So both the conditions are false. So OR means if both are false, the entire expression is false. So control comes out from the if. So print of mocks. So 90 will be printed. Here there is no exception. Okay, no exception is raised in the try block. So this except block won't get executed. So let the mocks is minus 90. Let the mocks is some instead of 100, let the student got 110 mocks. Okay. If mocks is less than 0, 110 is less than 0, false. 110 is greater than 100. 110 is greater than 100. So that condition is true. So one condition is true. So the entire expression is true. So this if block will get executed. Rise exception. So now the control will goes to the except block. Okay. So here this message will get printed. Mocks should be between 0 to 100. So this in this way we can raise an exception. Now let's see the practical implementation. Now let's see the practical implementation. So let A is equal to 10, B is equal to 0, try, print of A by B. Now let us have the except block, except, display some message. So print of, so what is this? This is what? Divided by 0. Divided by 0 exception. So divided by 0. Control S. Let us save the program. Let the name of the program is rise. RAI. Save it and run it. So here print of A by B. Here the denominator is 0. So here there is an exception. So whenever there is an exception in the try block, then Python interpreter raises the exception. So that exception will be thrown to the except block. Okay. So that will be done implicitly by the Python interpreter only. Divided by 0. So we got that message. If we want, we can throw the exception explicitly. So that is done by rise keyword. If B double is equal to 0, then rise the exception. So exception is raised by using rise keyword, rise. Next, specify the name of the exception. So here what is the name of the exception? Here exception should be predefined one, predefined exception, built-in exception class. Here we are throwing 0 division error. So except. So here let us have 0 division error. 0 division error. Control S. So here B value is 0. So now rise keyword rises this exception. So this exception will be thrown to this except block. So 0 division error. In 0 division error except block, what is the message? Divide by 0. So this message will be displayed now. So F5. So divide by 0. So this message got printed. So if we want, what we can do is, so in this argument, we can provide the message. So divide by 0. So this is one way. Another way of writing the predefined class argument. And now here we need to specify as E. Display print of E. So whenever the statement is executed, now this divide by 0, that message will be stored in E. So print of E means that message will gets displayed. Divide by 0. Now we got divided by 0 as the output. So in this way we can throw an exception. We can throw the exception. So try, if we want, we can throw the exception without checking the condition also. So try rise, let it is attribute error, let the exception is attribute error. So try attribute error. If you don't know the type of the exception, we can write exception also. This exception class can handle any type of exception. Now we will get message as, here when we are providing as ye, then we have to provide some message in the argument. Attribute not found. Attribute not found. Now that message will be stored in e and it will be printed. Attribute not found. So we got output as attribute not found. Okay. Now let us see another example. Now let us see one more program. So mux is equal to, let the mux is 90. So within the try block, let us check the condition. If mux value is either less than 0 or if mux is either greater than 100, then rise the exception. Rise exception. Otherwise, display the mux. Display the mux. So mux. Next, except, handle that exception. Except. So print off. So mux should be between 0 to 100. Here there is no exception, so there is no problem. So we will get message as 90. 90. Instead of 90, let us assume that we entered 110. Now there is an exception, so we'll get message as 0 to 100. Mux should be between 0 to 100. So in this way, we can rise an exception by using the rise. In this video, we are going to discuss about user-defined exceptions in Python programming. The name itself specifies the meaning. The exceptions which are defined by the user are called as user-defined exceptions. User-defined exceptions can also be called as custom exceptions. Why? Because according to the requirement of the user can create their own exception. So that's why we can call as customized exception, custom exception. We know that exception is nothing but a class. So exception is a class from which all the standard exceptions are derived. All the built-in exceptions are derived. We have several built-in exceptions in Python programming, such as zero division by error, attribute error, assertion error, file not found error, name error, value error, type error. Likewise, we have several built-in exceptions are there. So all those are classes. All the built-in exceptions are classes which are derived from exception class. So here our target is we want to create user-defined exception. So here user-defined exception is also a class just like the built-in exceptions. So here user-defined exception class should also derive from the base class exception. We know how to create inheritance. So inheritance means class, next derived class of base class name. So derived class name means user-defined exception class name, whereas base class name means what? Exception. Here let us create some user-defined exception class for a person eligible for voting or not. So when we can say that a person is eligible for voting, if the age is greater than 18, then we can say that corresponding person is eligible for voting. So if age is less than 0 as well as less than 18, then we can say that that person is not eligible for voting. So let us display that message here. So here first we have to create a user-defined exception class. Let user-defined exception class name is voting. So class voting. Here what is the base class name? Every user-defined exception class or built-in exception class must derive from exception class. Exception. Here this class doesn't performs anything, so the body of the class is pass. So pass is a keyword which doesn't perform any operation. Next, here we have to read the age. So age is equal to int of input of enter your age. Enter your age. Enter your age. Okay. So next, let us write the try block. If age is less than 0 or if age is less than 18, then we can say that that person is not eligible for voting. Now we have to raise the exception. We know that we can raise the exception by using the raise keyword. So raise space. Generally by using raise keyword, we can raise a built-in exception. But by using raise keyword, we can also raise user-defined exception also. Here, what is the user-defined exception? Voting is the user-defined exception class. So raise voting. So this voting is nothing but user-defined exception class name. We can raise this voting only whenever this class is defined. Suppose if this class is not defined, then the statement will display error message such as voting is not defined. Okay. Otherwise, if the condition is false, then we can say that that person is eligible for voting. So print eligible for voting. Eligible for voting. Next, except. So what is the name of the user defined exception class? Voting. Voting. Let us display some message. Print age should be greater than 18. So this is the program. Okay. So let us assume that we entered age as some 50. So if age is less than 0, 50 is less than 0, condition is false. 50 is less than 18, condition is false. So both the conditions are false. So whenever the condition, if both the conditions are false, then if returns false. So control comes out from the if, eligible for voting. That message will be printed. Here there is no exception in the try block. So except block won't execute. Let the person age is 15. So 15 means that person is not eligible for voting. Let us see here. If age is less than 0. So 15 is less than 0. Condition is false. 15 is less than 18. Yes, condition is true. So false true means or operator. True. So rise voting. Rise voting. So what is the purpose of rise keyword? It raises the exception. So that exception will be thrown to the except with voting class. Voting is the user defined exception class here. So A should be greater than 18. That message will be displayed. So in this way we can create user defined exceptions in Python programming. Now let us see the practical implementation. So class, that name of the user defined exception class is voting. So every user defined exception class must derive from base exception class exception. It doesn't performs anything, so pass. Next, let us read the age. Age is equal to, let the age is 50. Directly I am assigning the value. Next, try block. So when we can say that that person is not eligible, if age is less than 0 or if age is less than 18, then rise the exception. Rise. So what is the user defined exception? Voting. Otherwise, we can say that that person is eligible for voting. Eligible for voting. Next, let us define except. So what is the name of the class? Voting. Voting. So print off. Let us display the message. A should be greater than 18. Let us save the program. So this is custom exception. Let name of the program is CUS. Here what is age? 50. So 50 means that person is eligible for voting. So we will get output as eligible for voting. Now let the age is 15. So 15 means that person is not eligible for voting. So we will get message as age should be greater than 18. So in this way we can create user defined exceptions in Python programming.